Yeah. Yeah. So, good morning to all of you. A warm, can I start? Yeah. So, a warm welcome to all of the members here. And today, I welcome you to the developer training program on digital signature and public key infrastructure. We have the eminent guest in our program in the inaugural session. So, before we go to the guest, I request our executive director, Dr. S.T. Sursan, who is in CDAC Bangalore, is for an official emergency work. So I request him to deliver the welcome address. But before that, I'd like to just say a few words about him. Dr. S.T. Sursan is the Executive Director at CDAC Bangalore since August 2020. He has more than 3 decades of R&D experience as a researcher and manager in various domains of ICT. Prior to his current assignment, he has served as R&D manager at ABB and as a visiting scientist at the US Food and Drug Administration, FDA, USA, and he was also a group head at the Central Research Laboratory CRL of Bharat Electronics Limited and the scientist at these institutions. He is an alumnus of BITS Bilani and University of Arkansas at Little Rock, USA for master's and PhD program respectively. He is actively involved in the professional bodies including IEEE, ACM and IETE. He has contributed to various standard-related activities to IEC, ISO, BAS, and has served in various committees as well as task forces. He has multiple patents and research publications in peer-reviewed international journals and conferences. His areas of specialization include wireless communications, next-generation network, quantum computing, cyber physical systems, cyber security, industrial IoT, R&D management, and IPRs. He leads the domains including safety and mission critical system, quantum computing, cyber security, IOE, and HPC, etc. He is an outstanding professional, great mentor, industrious, and an altruist. With these words, I would like to welcome you, sir.
Yeah, good morning to all of you. Namaste. I hope I'm audible. Am I?
Yes, sir, you are audible, sir.
Okay, thank you so much. Welcome to the PK Developer Training Program. It's indeed an honor to be part of this morning celebrations. In fact, yesterday I was there. I was with our Honorable CCS sir at MIT. We had a short discussion. I was supposed to be staying there whole of today to be part of the event, but some exigency I had to come back to Bangalore yesterday night. My sincere apologies for not being physically there and be with Arvind Kumar sir and all of you. At the outset, let me welcome you all once again to the program. As you are all aware, the digital trust and the digital economy is thriving the country to the next level. And India is hoping to become very soon not only the top 3, but the ambition to go further up into the global economic value chain. The whole thing becomes possible only in a digitally connected and digitally trustworthy environment where economy can go forward. And one of the key ingredients for the digital economy is going to be our ability to create digital transactions of value that is not just mutually recognized, but also legally tenable through multilateral and bilateral agreements. And this calls for solutions that are robust and that are up to the mark, complying to not only just the international standards, but also best industry practices for secure development, in addition to just the compliance part. So from that perspective, today's event is very, very significant. And we have conducted a number of PK awareness program from school children to elderly to government officials to public at large, researchers, law enforcement agencies, defense professional, and so on. And we have always been supported unequivocally by our CCA. And along with him, we have the DCT Banati sir and the entire CCA team here. And this also has been strongly supported by NIXI because NIXI is the one which is now leading a couple of things from India perspective. One is how to make internet universally accessible, which is beyond just access to a few people or enabling in a particular category. And there are joint activities happening where CCA, MIT, and NIXI is involved along with CDAC. For example, the India Web Browser Development Challenge and so on. So the commitment and support from NIXI has also been phenomenal in the journey. And in this regard, today's event is extremely significant. And this is going to put us on the right path to say that not only India has the processes in place, the manpower, soft power, which everybody knows, but also the quality of software. Instead of being a offshore development center, becoming a place where we are delivering solutions and services that are made in India, made for the world, in line with the vision of the government of India and the Honorable Prime Minister. And that is where we all have to put our hands together and work on in delivering that. And in addition to whatever we are doing in simple PKI, there are two more activities that are extremely supported and continuously being augmented is proliferation is one part, standardization, proliferation and awareness. The second part is the next generation part, so that India's PKI infrastructure remains at par or better than rest of the world, so that we have a voice in international fora. And that becomes very critical for us. And that is the reason today, for example, we have a project that is looking at how to secure PKI from next generation or post-quantum era. And that is extremely important. And then another area that, along with CCSR and MIT, we are working is the Office of CCIs on the IoT side. How to make IoT trustable and bring the PKI infrastructure into that. So each of the vertical, if you look at it, they are extremely niche and brand new areas, greenfield for us. And India need not be a follower. We can be the leader. And we need not be on at par. At least we can become one of the advanced nations in those eras. And today, all of the developers who are present here, for us, it is a golden opportunity to become a global leader. And one day we should look at it, you becoming the leader with offshore centers in other countries which you are managing from India. That is the vision. That is what Arvind Kumar sir talks about it when we speak. How do we become, the trusted partner in the world, and people come to us looking for guidance. And it's a very, very honorable moment for all of us to be in this situation, that from being awareness and adoption, we are getting into development within a community-oriented manner. This partnership is going to take us a long way, and I have to thank Arvind Kumar sir and CCA team for the wonderful opportunity bestowed on us. And at the same time, he being someone coming from, standardization and quality control, in addition to being a mighty person, along with Banati sir, who is also from STQC background, they have also entrusted a third party to evaluate the impact of work that is being done in this area, so that there is an independent assessment. So this quality control, being able to know trusted but verified, that is the kind of concept that sir is bringing in. It is actually a different way, fresh thought. That is what enables us to dream and thrive for the global leadership role that we are looking at it. So thank you all for joining today. And I'm going to miss the physical interaction with all of you, at least today. But however, I will be online, and I listen to all the thought-provoking and very interesting discussion that are going to go happen on the development practices. Just to let you know, if any of you have a mathematical process or problem where you want to challenge, you need huge compute power. Under NSM, CDAC has enough compute infrastructure available, both as a data center as well as a HPC solutions, and you are welcome to use. You don't have to worry about the capital or investment. You worry about your problem, how to solve it as a developer or as a cryptanalyst and cryptographer and things like that. And we are there to support with all kind of infrastructure and support. And that is what we'll do. Any outcome that is coming out of the entire process will actually be with the help of NIXI, and they are there to take it forward from an India perspective. And together, it is going to be a wonderful collaboration going forward. Once again, I thank you all for the opportunity. I see the many more faces there in front of me. But in the interest of time, I'll say thank you. Sir, I'll come for coffee with you maybe tomorrow sometime. Thank you, sir. You all have a nice, wonderful time. Thank you.
Thank you, sir. Thank you for your wonderful words and encouraging thoughts. So as we move on, we have today Sri Ashish Banati, who is a Deputy Controller of Technology in the Office of Controller of Technology. He had an illustrious tenure and has made indispensable contributions throughout his extensive career at MeitY in various capacities. He has more than 3 decades of experience. His journey has been a series of noteworthy achievements in various leadership roles and pivotal roles. His contributions to ISO, IEC, IEEE, JIS, and JSS made remarkable benchmark. And he has also overseen a team of engineers, and fostering a culture of innovation and excellence has been highly commendable. The successful management and motivation of his test teams for significant e-governance projects, including NSDG, MCA 21, Passport Seva, they stand as a testament to his strategic vision and commitment to promoting indigenous token solutions and standardized protocols. He has led the Indian Common Criteria Scheme at STQC and spearheading the biometric device certification service, which has acknowledged and by esteemed individuals like Sri Nandan Nilekani, and to showcase his profound influence and expertise in this domain. In his role as DCT, his diligence and dedication in regulating digital signatures and driving global mutual recognition have significantly contributed to the safety and security of the entire digital ecosystem. His thoughts, especially related to token software and common API tools for fraud prevention, etc., has been seeing recent developments, and projects have been undertaken in this particular domain. We welcome you, sir, to address the gathering.
Hello, yeah. Good morning, dear esteemed guests, distinguished participants, my colleagues, and ladies and gentlemen. I'm deeply honored to sitting before you today as we inaugurate the comprehensive training program on digital signatures for application developers. This initiative of CCA and CTAC Bangalore marks a pivotal moment in our journey towards meeting the burgeoning demand of proficient professionals in the realm of digital security. In today's rapidly evolving technological landscape, the significance of secure digital signatures cannot be overstated. As we witness a paradigm shift towards digitization across the industries, the need for skilled developers capable of implementing robust security measures becomes increasingly paramount. The training program has been meticulously crafted with the aim of equipping developers with the requisite knowledge and skills to navigate the intricate domain of digital signatures. Through a blend of theoretical insights, concept of legally valid digital signatures, and its practical applications, the participants will gain a comprehensive understanding of industry best practices, enabling them to adeptly address security challenges, mitigate risk effectively. Moreover, this program also brings to the fore the CCA's unwavering commitment to fostering innovation and excellence within the developer community. Some of our partners will be sharing their achievements, demonstrating their innovation capabilities, and zeal for indigenization. Such technological innovations shall definitely contribute towards fortifying the broader digital ecosystem against emerging threats. As we embark on this transformative journey together, I urge each participant to approach this training with diligence, enthusiasm, and a thirst for knowledge. Embrace the challenges that lie ahead, for they represent opportunities for growth and advancement. I extend my heartfelt gratitude to all those who have contributed to the realization of this initiative, including our esteemed partners, instructors, and organizers. Your dedication and commitment have been instrumental in bringing this program to fruition. Let us reaffirm our collective resolve to safeguarding the integrity and security of digital transactions and embrace these innovative technologies. Together, let us pave the way for a future defined by trust, integrity, security, and technological excellence. Thank you.
Thank you, sir. Thank you for your motivating and encouraging words. We'll go into that. So now we move to the key part of the inaugural session. We privileged to have Sri Arvind Kumar sir, who is the controller of certifying authorities. He was earlier group coordinator R&D, electronics and cybersecurity. He has envisioned several projects in the public-private partnership mode with industry and startups, academia and government. He had earlier also served as the Director General of STQC. Coming to his educational background, he did his Bachelor of Engineering in Electrical, Electronics and Communication Engineering from IIT Delhi. He also did his MTech Management and Systems from IIT Delhi. He has a very rich experience in mentoring startups in ICT and cybersecurity, and his contributions from the Office of CC has been astounding with support for various international conferences, international events, supporting the mutual recognition of Indian digital certificates across the world. On behalf of the gathering, I extend my sincerest gratitude for his exceptional contributions and unwavering commitment to excellence. His leadership continues to inspire us, and his contributions remain pivotal in propelling us towards even greater achievements. Welcome, you, sir.
Good morning. Dr. Sudarshan, Executive Director, CDAC Bangalore. Dr. Balaji and team from CDAC Bangalore. Mr. Ravi Harmiji from Precision. Dr. Ompal from Delhi University. CDAC Noida colleagues. Colleagues from CCA office. Representative from industries, those who have joined online as well as who are present in this room. I think today's topic of this training of developers on digital signature and PKI is a very pertinent topic. This training program we have designed in such a way that it's more of a hands-on to give some kind of insight into how the digital signatures can be attached to various information systems, various applications. As all of you know in the previous addresses that Digital India program of Government of India is one of the very flagship program, and we have seen the success of this population scale DPIs which are already in place, be it our Aadhaar digital system, Aadhaar system for identity, or it's a UPI for payments. India has shown the way to the world, being the leader of the digital public infrastructure. We have seen the growth. We have seen all of us have become now accustomed to using digital systems for digital processing of information and using digital devices. At the same time, we find there is a cyber threats which is looming large on these data breaches. They are imposing serious threats and risk. If you look at this kind of advantages of having PKI in place, public key infrastructure is the only solution, is the solution in cybersecurity, which can provide a framework for verification of authenticity and integrity of the various digital transactions. If you look at the advantage of having PKI in place, it has got huge advantage of adaptability to various technologies As technologies are changing due to innovations, it continues to stand with various upcoming technologies of IoT, blockchain, cloud computing. The way it progresses, the PKI provides a very strong base of security for all of them. If you look at the PKI facilitation for secure communication and data exchanges in the cloud computing, by encrypting very sensitive information, verifying the identities of users, and we find that clouds become secure due to the implementation of PKI in the systems. If you look at the IoT, PKI ensures the integrity and authenticity of the data transmitted between interconnected devices, and it safeguards the unauthorized access and manipulation. Besides the technological development, the technological revolution, if you look at the legal compliances, PKI plays a very important role into that. The regulatory compliances like GDPR, HIPAA, PCI DSS, if you look at all these, the robust security controls gets implemented through public key infrastructure. So if I look at the kind of PKI implementation, it is providing a very good source of trust and confidence in digital interactions and various digital transactions. If you look at the kind of sectors it has come through, there it is cutting across various sectors of health, education, government portals. Everywhere the PKI gets implemented and secure the systems. It really gives you the identity theft. It protects you from identity theft, frauds, or any cyber attacks. So the cyber threats are getting sophisticated over a period of time. PKI still remains a fundamental tool for mitigating these risks. By encrypting sensitive data, authenticating users, devices, and systems, and detecting and responding to the security incidents in real-time basis. PKI helps organizations to stay one step ahead of cyber criminals and protect their digital assets from unauthorized access. If you look at in brief, we look at PKI is important in today's digital world, cannot be overstated from the security data, these kind of technologies which are coming up. So the present, because if you look at the PKI CCI office being the regulator of the PKI framework in India, we have seen the PKI implementation in the various applications. It still needs some improvements. The kind of reliable systems which gets implemented through PKI still gets to be evolved. A lot of guidelines have been issued by the Office of CCA. They need to be implemented for attaching the digital signatures to various applications and systems. So digital signatures implementation, which is the key area for authentication. This program has been brought out by CDAC Bangalore. They are the implementer of the program on capacity building in this domain under the ministry. So this program we are targeting to the developers or to the application owners, those who want this to be implemented in the correct manner. We'll have a discussions on specific guidelines to be explained by one of our officers in the subsequent sessions. He will be telling you about how we can take it forward in implementation. And I hope this will provide a very good platform to all the developers and interested parties over here, that they will be able to understand the requirement and rightly implementing the system of digital signatures in a harmonized way, in a way where it can be interoperable systems can be made available. So with this, I would like to wish you all a very interactive session. You try to interact as much as possible with the presenters over here to understand the requirement. They are available to give you hands-on practices on the whole subject, so that you ensure that the guidelines of CCA, the whole concept of PKI implementation through digital signature in various application systems gets addressed in a very robust way, and that will provide the basis for the security of various DPIs in place. With this, I wish this training session great success and very fruitful interactions to go ahead. Thank you.
Thank you, sir. Thank you for the inspirational words, especially to focusing on development and contribution of PKI in DPI infrastructure and underlying the importance of today's program. With this, definitely we are geared up to this conducting the program and ensuring that it reaches the maximum benefit. Now I request my colleague Dr. Misbah Uddin, scientist at CDAC Bangalore, and he is also leading the business division and ACTS team to propose the vote of thanks.
Good morning, everyone. Thank you very much, Dr. Balaji. I would like to propose a vote of thanks, and it will not be complete, starting with thanking Shri Arvind Kumar sir, Controller of Certifying Authorities, with sir's continuous effort as well as motivation and the ideas that he drives, and the way, the vision that he is trying to implement. With that, we are trying our best to create awareness across the country. Thank you very much, sir. And after a long time, we are conducting this developer training program. I've been associated with these events for a long time, but I think there was a gap of some 5-6 years. Now again, we have come back to the developer training program, and it is obvious that there will be very, few people who will be attending this, because developers, that too, developing an application in the cryptographic domain and trying to understand how to implement the digital signature technology. This is a kind of niche area for them. So I hope that by the end of the day, some sort of understanding will be created, because we are going to give the training in Java as well as Python. So how to use, how to implement digital signature with Java, in Java as well as in Python. So that is the way that we are now moving ahead with our awareness programs beyond the regular awareness training programs, like what Executive Director Dr. Sudarshan has mentioned, that beyond school children till the experienced and senior members. Now we are also again going back to the developer community. Thank you very much, sir, for driving this vision, and I also thank Shri Ashish Banati, sir, who is the Deputy Controller of Certifying Authorities Technology, and also all the CCA members who are here, ACTs, as well as Deepak ji, Dr. Pandian, and nonetheless, Dr. S.D. Sudarshan, for giving us the apt inputs always for implementing these ideas, and also, conducting the events across India. My personal thanks to the team, PKI team, as well as the admin support. Before concluding my vote of thanks, I request Dr. Balaji, as a token of gratitude, could you please present the shawl to the chief guest, Shri Arvind Kumar sir. I request Dr. Balaji to present the shawl to Ashish Banati sir as a token of gratitude. Our executive director is not here, so we'll anyhow virtually sir is available. So I also request Dr. Balaji to kindly present the shawl to Dilip Burman sir also. And to Mr. Shamsuddin Khan. Thank you all. With this, we conclude our inaugural session. We'll break for tea. And the tea is served there at the ground floor. Actually, we have to climb down and then go on the left side. I think we'll assemble back at 11:20. Thank you very much, sir.
One.
Welcome back. Recording. Okay. So today, as we start the program, CCS sir has explained about the importance of the public infrastructure and trust requirements in digital public infrastructure, that is DPI. So to elaborate on this particular topic further, today we are privileged to have Sri Tanmay Chakrabarti Ji from CCS to deliberate and deliver the talk on the role of public infrastructure in digital public infrastructure. We welcome you, sir.
Thank you. Thank you very much, Balaji. Thank you for having me here. We had a very interesting session in Bangalore some months ago that CDAC had convened. And I really appreciate the workshop that is happening today, because I think the kind of work that the CCA and his team is doing around the country, in some sense, in a very simplistic sense, the way I look at it is bringing order to the chaos. It's a tremendous contribution and a catalytic input that the CCA and his office is bringing to large enterprise-wide application usage and the aspects of security and non-repudiation and everything else that's attached to ensuring that there are no loopholes, there are no major incidents that happen, because we all know what happens in an uncontrolled cyber environment. So I think the role that CCA and his team play is a very, very vital role. And I recall, as the head of the TCS government business some years ago, we were some of the early adopters of the digital signature regime for large government enterprise applications, beginning with the first one, which was MCA 21, which was the first mission mode program of the government of India then, for the Corporate Affairs Ministry, where there was a huge transformation that came about in the government to business interface. Corporate Affairs Ministry is all about the incorporation of companies, their filing of annual returns, and several other 54 types of interactions that companies have with the government on an annual basis. And those were the formative years of the beginning of the certification authority regime in India. And I must commend that it has come a long way, where many more such large, voluminous user base enterprise applications have, in fact, some of them have been mandated to have digital signature as an embedded part of the application usage for identity and establishing a very secure transactional interface between users, duly facilitated by the digital signature regime. So, as most of you are aware, that more and more applications, more and more infusion of IT in the day-to-day lives of average Indian citizens is the way forward, is the only way that we are moving ahead. And therefore, the heightened increased need for securitizing those interactions becomes absolutely paramount. And the way I look at the whole digital signature regime in public infrastructure is that it has to become an imperative and embedded component of every single application that the developer community conceives or conceptualizes from scratch. You must begin with the fact that you need to have identity, you need to have signature, digital encrypted signature embedded for anything that you are developing, and that should become the way of the world in India, where I foresee, let's say in the future, when we look at things like e-elections, e-voting, and that's the furthest that you can go, including things like the ability to buy tickets online, every transactional activity on the enterprise application platform needs to be embedded with a digital signature regime. And this is where the office of the CCA has been able to create a mahol, if I can call it, an environment of enablement. And therefore, much of the large application usage in the country is largely unaffected by any of the cyber hacks or cyber incidents that we see or hear about around the world. So it's a tremendously positive and catalytic activity that I commend the CCA and the team and CDAC as an entity to continue to promote both within government as well as in the private sector. And all of this augurs well for a very robust application usage regime in the country. So I think I don't need to define public key infrastructure is a set of policies, procedures, hardware, software, and standards used to manage digital keys and certificates. It provides a framework for securing communications and digital identities over a potentially insecure public network like the internet. We all know some of the challenges that are being faced on a regular basis by many of us using the internet. So therefore, there is a need to have a layer which will securitize and ensure that there is authentication as well as identification and non-repudiation every time we use a public network platform like the internet. PKI is commonly used to enable secure data transfer, authentication, and authorization in various applications, including web browsing, email, secure access to networks. Some of the key components of PKI include a digital certificate, which is the very heart of the core component, if I can call it. Digital certificates, these are electronic documents that bind a public key to an individual or entity certificates as issued by the certification authority, the CAs, and are used to verify the authenticity of the public key owner. Public and private keys is another component. A key pair consists of a public key which is shared openly and a private key which is kept secret. The public key is used for encryption and the verification, while the private key is used for decryption and signature, signing. Certification authority, and we have some certification authorities in the room, are entities responsible for issuing digital certificates to users. They verify the identity of the certificate holder before issuing a certificate. Registration authorities are responsible for verifying the identity of individuals or entities before they are issued a digital certificate by the CA. Certificate revocation list is a list of certificates that have been revoked by the CA before their expiration date. It helps in checking the validity of the digital certificate on a continuous basis. So these are some of the components that comprise the whole PKI regime. And coming to digital public infrastructure, it refers to the technological foundation that enables various e-governance services and digital interactions between government and citizens, G2C. It encompasses a wide range of technological, including databases, networks, cybersecurity measures, and more to support digital services provided by government entities. When integrating PKI into DPI, digital public infrastructure, it often involves implementation of a secure and trusted infrastructure for managing digital identities, securing communications and ensuring the integrity and confidentiality of data in digital government services. PKI plays a crucial role in establishing trust in online transactions and interactions between citizens and government entities. The role of PKI in digital public infrastructure includes an activity very crucial, authentication. PKI enables secure authentication in a digital interaction. Government services can use digital certificates to verify the identity of the individuals accessing digital platforms or making online transactions. Digital signatures, PKI allows the use of digital signatures which help in verifying the integrity and authenticity of digital documents. Government documents, contracts, or transactions can be digitally signed for added and additional security. Secure communications. PKI ensures secure communications between citizens and government entities. Encrypting data using public key cryptography ensures that sensitive information is transmitted securely over the networks. Trust in e-governance services. By implementing PKI, government entities can establish a trusted environment for citizens to interact with digital services. Trust is critical and crucial in areas such as online tax filing, income tax. Already e-filing is very much in vogue in India. In the future, we are definitely going to see e-voting in India. It's in the part of the roadmap, and accessing government databases for crucial information. Data integrity. PKI helps in maintaining the integrity of the data. Digital signatures ensure that data has not been tampered with during transmission or storage. This is very, very applicable when you are accessing information, let's say with regard to land records or any of the certificates that are issued by government, to ensure that there is no tampering involved in the original information remaining the same form as it is as a part of the government record. Compliance and regulation. Many regulatory frameworks mandate the use of secure digital communication in government services. PKI provides a framework that aligns with these compliance requirements. The challenges and considerations, of course, of the digital signature and PKI regime include the key management process. Proper management of public and private keys is essential to the security of PKI. Safeguarding private keys and ensuring that they are not compromised is very critical. User education, awareness, ensuring that users understand the importance of digital security and how to use digital certificates is crucial for the effective implementation of PKI. Very often you will come across situations where digital signatures, certificates are compromised by handing it to either the PA or the other person in the office. So one has to be very cognizant of the risks attached to such compromises. Scalability is another one, as India is absolutely, we have plenty of numbers. So to be able to ensure that any system developed can scale to the volume expectations of usage in the country is another very, very important factor. And their ability of the application to handle peaks and troughs of usage is another very important factor that needs to be considered when you architect a solution to ensure scalability. Interoperability, ensuring interoperability between different PKI systems is important, especially in public infrastructure, where multiple entities may be involved in a heterogeneous environment, cross ministries, cross departments, people having developed applications using different platforms. The interoperability of such a system becomes very important across heterogeneous technical platforms. And of course, regulatory compliance, adhering to relevant regulations and standards is crucial. Different regions may have specific requirements for the use of digital signatures and certificates. Overall, PKI within DPI contributes to the security, privacy, and reliability of digital interactions and enables secure authentication, data protection, and the establishment of a trusted environment for digital services. I would urge the digital developing community, such as the ones who are present in the room, to conceive of a completely PKI-enabled digital India. That is the direction in which India is moving, and the CCA is playing a pivotal role in increasing the awareness, usage, and adoption. Because with the, as I said, bringing order to the chaos is the real silent work that the CCA is doing, ensuring the adoption of the digital signature regime. I also foresee in the future that non-repudiation is going to become a very important element in enterprise application usage in the country. A digital signature, which is a dongle, can be compromised to some extent where you can actually share the digital signature physically with somebody else. But if you combine a PKI, a biometric component to the digital signature and create a combined device, which is two in one. You ensure not only digital signature, authenticity, identification, and security, but you also ensure that the individual cannot escape the non-repudiation clause of the IT Act in the future, when he cannot deny, he or she, that it was he or she who actually did that online transaction or accessed the database or queried an application. So I foresee in the future, and I'm sure the CCA and his team are working towards this in this direction, that India will have a very mature PKI authentication, self-identification through biometrics, combined with digital signature, all in one device, duly indigenously developed in the country, because we have the capabilities of doing so in the country. And this can become a model for many, many of the other developing countries, where we can actually take this as a template for others to also benefit from a digitally PKI-enabled regime that I foresee India in the future. So thank you very much for your attention, and I wish this conference the very best. There are many technical sessions that are coming in the afternoon, and I'm sure that you will have a lot of interactions and Q&A to get the queries. And most importantly, when you go away from this conference, to spread the message of a PKI-enabled enterprise regime that should be the one that India should have in the very near future. PKI, digital signature, biometric authentication for every application by default should be the mission mode mantra for all of us going forward. Thank you again for your attention.
So thank you, sir, for wonderful lectures. Actually, you also signified the key points of the public key infrastructure and how it will be having a key role in the DPI, and also the various initiatives of the CCA in which it is being strengthened. As a token of small appreciation, I request Dr. Misbauddin, my colleague, to felicitate you with a shawl.
Thank you. Thank you. Thank you again for having me.
Next. So as we
Thank you for having me. Thank you.
Yeah, we can connect. Yeah. So now I request my colleague Dr. Misbauddin to provide the technical background behind the concept of digital signatures and public key infrastructure, which will set the base for the further sessions, including the demonstrations from industry, as well as the programming, which we'll be covering in the later part of the day, especially related to programming in Java and Python on cryptographic programs. So over to you, Dr. Misbauddin. As he sets up, we will enable, meaning, yeah. So yeah, he's ready, and
Yeah. Good morning, everyone. We'll start the session, and I'll rather going after the slides. Yeah, I'll do that because I have certain demos also. So rather than going directly slide by slide presentation, just I'll give you a brief because many of the already experts are here who are already working, and there are a few of the people who have who are exploring this particular technology. So I'll give the background and then directly I'll go on the demos so that it will be easy for us to understand. At the same time, it will save our time as well. I already have it. Just check. Connect with mobile. Meanwhile, I'll just yeah. Okay. Okay, we are starting the presentation with the comparison of physical documents, integrity of physical document versus the digital document. There is a possibility of breach of integrity in physical documents. Here is the example that is given here. For example, I have written a note or I have written a letter, anything. And then after signing, I have given it to the approving authority. And once the approving authority receives that particular document, he feels that this cannot be approved, this request cannot be approved. So what the approving authority has done is he has written not approved as a comment and then he signed. Now we are not tampering the signature, we are not playing with the signature, but there is always a possibility that the person who has submitted the request, once he gets this back with the comment of not approved, then he can add a E there, which makes the document meaning complete, which changes the document meaning. So the not approved becomes the not approved. Okay, and we have not played with the signature. So here, the most important aspect that we need to understand in physical document, physical world versus the digital world is, in physical world, in hand signature, the content is independent of the signature. So whatever content I have here, let us say this is my content, right? And this content, when I'm signing this particular content, the content as well as the signature are different. We know that in hand signature, our signature will always be same, irrespective of the content we sign, right? Basically, it is an endorsement of the content that we are signing. But the moment the content changes there, it does not reflect that change in the signature, because our signatures are unique and our signatures are static in nature. Whereas when we talk about digital signatures, digital signature technology is dynamic in nature. Why it is dynamic? Because the content is dependent on the signature. The signature is dependent on the content. The signature is dependent on the content. How the signature is dependent on the content, that background I'll give you. So here, I can say it's not a weakness, but yes, the limitation of hand signature is the moment the content changes, it does not reflect on the signature, because signature is static. Okay. So here, not approved and not approved is the best example of understanding this particular aspect. Okay. So there is another example here of a check being signed. Okay. And this check is of 6,000 rupees. So since the space, little bit of space is there, so the signature is not tampered, and there is a gap between 6 and 1,000. So the person has added a 0 without rewriting the check content also, or without tampering the check content as well. And then within that space, he very neatly wrote TY. So the check has become 60,000. Okay. So here there is a clear case of breach of integrity in the physical document. And as just now I said, that the physical documents, the hand signature, content, as well as signature are independent of each other. So here, this is another example of it. Whereas when you talk about the digital signature technology is the one wherein the content is dependent on the signature. Okay. I'll directly go to that particular part. So the signature, when we talk about the elements of trust, we have 4 properties: privacy, which is also called as confidentiality, most importantly, and then authenticity, integrity, and non-repudiation. With the digital signature, you will be able to achieve authenticity, integrity, and non-repudiation. In fact, with the digital certificate, if we have an encryption certificate as well, then we'll be able to achieve confidentiality as well. So basically, what I'm trying to say is, with PKI in place, you will be able to achieve all the 4 properties: confidentiality, authenticity, integrity, and non-repudiation. But digital signature technology will enable your application or your document to achieve all the 3 authenticity, integrity, and non-repudiation out of 4 properties. Okay. Now, to achieve that digital signature or the digital signature technology, I'll just give you a demo first. Is it visible? Yes. So this is a demonstration of digital signature. Let us say we don't know anything about digital signature. Okay. So from here, I'm trying to build up this particular presentation now. So I have my token connected to it. Okay. So what is this token? It is a crypto token, which is FIPS 140-2 compliant. Okay, which is an international standard, obviously. So this token contains a digital signature certificate. Okay. Now, what is this digital signature certificate? A digital signature certificate contains a public key. Okay. And it's another version like .p12 or .pfx file contains your private key as well. So here, there are 2 files that are there in this. Actually, there is one certificate which is kept in 2 different files. So here in crypto token, first of all, why do I need crypto token, and why do I need the digital certificate? Okay, what is this public key and private key and all? Generally, we give example of symmetric key cryptography and asymmetric key cryptography. The door locks are synonymous to your symmetric key cryptography, because one key will be used for locking as well as unlocking. That is what is symmetric key cryptography. Similarly, asymmetric key cryptography requires 2 different keys, one for encryption, one for decryption. So in non-technical terms, you can call it as one for locking and the second one for unlocking. Now, for locking, which key is to be used, public key or private key? That depends on what property you want to achieve. Suppose if you want to achieve authenticity, integrity, and non-repudiation, then you have to use private key for encryption. Once you use private key for encryption, that means locking, you have to decrypt it with public key. Okay. So the opposite keys are to be used for any feature that you want to achieve. Now, let me give you a real-time example of that. Like we have car remote locking systems, right? So it will have two buttons, one for locking, one for unlocking. So two buttons are there and it has exclusive functionality. When the car is locked, I have to press unlock button only in order to unlock it. If I keep pressing lock button, it will not unlock because that particular functionality is exclusive for that particular button. Similarly, when I decided that I want authenticity, integrity, and non-repudiation, so my locking key becomes private key. Okay. So when I lock it with private key, the opposite key is public key. So I have to unlock it with the public key. Whereas if I want confidentiality, then I have to use the receiver's public key. Okay. When I use your public key, so I'll be able to lock the content and then send it to you. Okay. When I send it to you, which key you have to use? You have to use your own private key because opposite key is to be used. Okay. Now these keys are actually digital values. It is a digital key. It's not a physical key that you can hold in your hand. So these are digital keys. So digital keys obviously have to be kept in some electronic document. Like my presentation is there in an electronic document called as .pptx. Okay, my CV will be there in an electronic document called as .pdf or .docx. Similarly, there should be a electronic document which contains these key values. Okay, and in India here, as per the CCA guidelines, we use 2048 bit size of key. Okay, so this 2048 bit key is to be kept somewhere in the electronic document. That electronic document is called as digital signature certificate. Okay, and generally it will be of .crt format. Okay, .crt, .cer, different formats are there. So that particular certificate which contains the public key is called as the public key certificate. Now, what tool is used for creating these certificates? There are many tools, open source tools are also available, which is used for creating these keys. Okay. So any tool can be used for demonstration purpose, but the most important aspect is how do you relate that particular public key with a person? How do you connect that person? How should I prove that this key belongs to me? That is where the certifying authority comes into picture. Okay. So certifying authorities are those authorities who are responsible to issue the digital certificate. Okay. So in India, we follow hierarchical trust model. Okay. So at the top level, the root certifying authority of India will be there, RCAI. Okay, which is operated by Office of CCA. CCA himself, CCA sir was here. So he is the highest digital trust person in India from the digital trust point of view. So the CCA is at the top level. Then in the intermediate level, all the CAs are there. Okay. And then at the lowest level, the subscribers will be there. So we get the digital certificate endorsed by or certified by the certifying authority. Okay. And then the CA gets the licenses from the CCA. This is what is the model. I'm just trying to make it more crisp in the best interest of time. So this is the hierarchical trust model that we follow. Once I get the digital certificate, now I'm enabled to digitally sign a document. Now here, that is what I'm trying to show. First, I'll show it in MS Word format. Then I'll go to PDF format as well. So I go to File and then in Protect Document, I have an option called Add a Digital Signature. Okay, I'll go back again, just as a repetition. So I click on File, then in Information, I have one option. This is the latest version of Office. So other versions, somewhere you just need to search that, wherever this Protect Document option comes, and then click on Add a Digital Signature. Once I click on Add a Digital Signature, now it is looking for my certificate. It's already connected here. Now it is trying to search and it has found here. Okay. These two options are optional provided by MS Office. Okay. I'm not bothered about that. Now here, this is what is more important for me because it has extracted my certificate details from the certificate that I have here in the token. Okay, signing as Mohammad Misbahuddin, issued by eMudra Sub-CA for class 3 individual. Okay, so I'll just click on sign. Now, what is happening in the background? If you look at here, creating signature. Okay, so what is a signature now? First of all, we need to understand. Signature is a two-step process. Number one, whatever content you want to sign, whether it is text, whether it is PDF or image or video, whatever you want to sign. So that particular content's hash will be computed. Okay, using generally it will SHA 256 secure hashing algorithm 256 or SHA 512 will be used generally. Okay, so now the first step is whatever content is given as an input to the digital signature algorithm. So here it is RSA. So the first step, as part of the first step, it computes the hash value, and this hash value goes into the crypto token. Okay. Now in the crypto token, my private key is there. Now the second step is the output of hash function is called as message digest. Okay. This message digest is to be encrypted with my private key because I want to achieve authenticity of the document, integrity of the document, as well as non-repudiation, because later on I should not be able to deny saying that no, I have not signed. So these three properties are achieved using my private key. So my private key is there in the crypto token. But this is the private key. So as per the standards, this private key is to be protected with a PIN or a password or a passphrase. Okay. So here also my private key is protected with a PIN. That is why it is asking me the PIN. Once I enter the PIN, what happens is it enables the private key, activates the private key to encrypt my hash, which has gone into the crypto token. Okay. And once it encrypts it, now the digital signature value plus the digital signature certificate, my public key certificate, comes out and it gets attached to the document. This is the simplest process. Okay. So now I'm entering the password. Now here it is written that now it is already digitally signed. Your signature has been successfully saved with this document. If the document is changed, your signature will become invalid. Okay. Why it will become invalid? Because if, first of all, it will not allow. Okay. But even if I go into settings and try to change, the content of the document, what happens is the hash value will change. Okay. So what is a digital signature? Digital signature is nothing but the encryption of the message digest of the document. Okay. That is what is the digital signature. Now, what you are trying to do, already this digital signature, which is the encryption of the message digest, it is already embedded into the document, and you are trying to play with that content. You are trying to modify that content. The moment you try or you do the modification, the hash value of that content will change. And this hash value and the hash value which is encrypted will not match. Okay. So that means the digital signature, all the integrity or the authenticity is tampered. Okay. Or breached. That is where, first of all, the applications do not allow, even though if you try internally also, then this is what will happen. So that is why it is saying that if the document is changed, your signature will become invalid. Generally, it removes the signature from the document itself. Okay. Now, if you try to compare this particular example with the example which I have shown with the hand signature, right? Not approved, not approved. Okay. There, the signature did not change. Here, for every different content, my signature resultant value will change. Okay. Now that means on a single day, if I am signing 10 different documents, I have signed one indent, I have signed one invoice, I have signed some application. Okay. Leave application or something. So all these three are different contents. So my signature resultant value will be different, but hand signature provides the identification also, right? When you see a signature, you will understand that this is your director's signature. So that means the hand signature provides you identification. Since the signature is same, identification is easy. Whereas in digital signature, since the content is changing with every changed document, signature is changing with every changed document, how will you relate these changed signatures with a particular person? Okay, that is where your public key certificate comes into picture. Okay, so that public key certificate says that this particular document is signed by so and so person. Okay, even though the resultant value is different. Now I'll click OK. Now it is saying that it is a signed document. This document has been signed and marked as final. That means you can no longer edit this document. It should not be edited. If anyone tampers with this document, the signatures will become invalid. Okay, let us go and see. So here, the document is digitally signed now. If I try to edit it anyway, so it is giving me an error here. Okay, not error, alert message here saying that editing will remove the signatures in this document. Do you want to continue? I have not yet edited, but I'm just trying to edit it. So the moment I click yes, it will remove the signature from the document itself, because as I told you, first of all, it will not allow you to edit. But here, since the option is enabled for editing, if I click, it is saying that the signature has been removed and the document has been saved. This is how, from the trust point of view, and from the integrity point of view, the digital signature provides you better security strength comparing to hand signature. Okay. Now I'll go to PDF document. This was a recent, court verdict that has come in Bangalore. So I just made a copy of that. I should not digitally sign, but just for demo purpose, I'm showing it. So in the recent version of Adobe Acrobat, it is providing you the option here, use a certificate. Okay, I click on this. Here the option of digitally sign is there. Okay, I click on this digitally sign. It is asking me basically where do you want to place your signature. It is just a matter of representation. MS Word represents digital signature in a different way, while Adobe Acrobat represents the digital signature in a different way. Yes.
Can we add signature appearance under the Word document or the signature container under Word document like of PDF is showing?
It will not allow, no. It's not on open source. You may try it in open office, something like that. Like what PDF allows you to add, in that way you are saying. No, it generally it will not allow.
PDF and some library like iText or the common library, which is allowing to add container type, container or signature appearance under the some of valued axis.
It maintains PDF maintains its own repository actually.
Yes.
Its own certificate repository, whereas MS Word, MS Office applications maintains its own separate repository.
I think you are telling about AITL, Adobe Approved List.
Yeah, yeah.
So Microsoft also having the signature report.
Yeah, it will have its own repository. Yes.
Why not they are displaying?
Sorry.
Why not they are giving the option?
Yeah, there are a lot of other applications also where they do not come together. Okay. Like Google has its own authentication and single sign-on, whereas Facebook has its own, and Microsoft has its own, like passport kind of applications, but they do not gel with each other. So interoperability, not interoperability, basically that connectivity from the user perspective, it will be easy for all of us, but they'll not, that is their business policy. Okay. Yeah.
So we can check through the signature tag only.
Yeah.
Thank you.
Yeah. So presently I'm placing the signature here first. Okay. You can place anywhere. Generally at the end of the document we place, but just for demo purpose, I'm placing it here. Now it is actually, as of now, one digital certificate is installed on my machine. So it is showing me that particular option. So Mohammed Misbauddin and all. So this is how it will come here. It's up to you to decide how do you want to represent that digital signature. And here there is an option called lock document after signing. Suppose if you are the last signer, then you can click on this option, lock document after signing. Okay. And then you click on sign. Again, the same thing, hash is being computed and then the digital signature is being created. So let me share it on desktop with a different name. Okay. So since the digital signature as well as the public key certificate is going to get added to the document, that is why it is becoming a new document now. Okay. That is why it is asking me to save again. So once I click on this, it is asking me to enter the password here. So once I enter the password, now it is digitally signed. Okay. So if I click on this, it is already saying that this is a valid signature. Signature is valid, signed by Mohammed Misbauddin, having an email ID registered in the certificate as misbah@cdac.in. The document has not been modified since this signature was applied. The document is signed by the current user. Now, if you want to look at the signature properties, you go here and then click Show Signer's Certificate. Okay. Now here you can see the hierarchy. Mohammad Misbauddin has got the certificate from eMudra Sub-CA, which is a sub-CA of eMudra CA. And eMudra CA is a licensed CA of CCA India. Now, if you want to see more details about my certificate, okay, so it is a personal certificate. And then if you look at the details here, now it is version 3, signature algorithm that they have used. I mean, when you get the digital certificate, the public key certificate will be signed by the CA, right? So what algorithm they have used for signing? It is SHA 256 and RSA. And subject is basically my details. CN is common name, Mohammad Misbauddin. My serial number, state is Karnataka, postal code, and all those details are given. Now, who is the issuer? Issuer is eMudra Sub-CA for class 3. So this is my class 3 digital certificate. And organization unit is certifying authority and all. This is the serial number, which is very important. This serial number is unique, and it is very important from the perspective of CRL, Certificate Revocation List. Okay, so I'll come to that point later. So then validity of the certificate. Okay, the validity is from 28th March 2022 to 3rd March 2024. Okay, so basically I have taken this certificate for 3 years. But here the validity is showing as 2 years. I think CCA office will be able to elaborate more on this. But I spoke to eMudra. I asked them that why, when I paid for 3 years, why you are from eMudra? Okay. 2 years because their certificate is getting expired and they're.
Under the 2014.
I think.
So 2014 can be expired on March 6th.
That is what they told me. And then once their certificate is renewed, they said that they will again reissue or renew my certificate. Is it right? That is what is the answer I have got from them. Okay. 2000? Okay. So anyhow, this will be renewed. So CRL distribution point, if you look at this one, something. Okay. So eMudra basically maintains its CRL, Certificate Revocation List, at this particular URL. Okay, I'll show that later. I'll check whether my net is working. Yes. HTTPS. Yeah. So this is the CRL I'm downloading. Okay. Download insecure file. I'll come to this also. Whenever, during the validity period, suppose if I lost my certificate or if my keys are compromised or if I feel that my keys are compromised and I have requested for revocation of my certificate, then my certificate serial number, which I had shown you there, that every certificate will have a unique serial number. With that serial number here, it will be recorded. So there are basically 3 fields that will be there. One is the serial number, second one is the revocation date, and the third one is the reason for revocation generally. Okay. So like here, if you look at serial number so and so, revocation date is 27th August 2014 and CRL reason code is key compromise. So this is the revocation list that is maintained by every CA. Okay. I'll go back to the demo part. Okay, the major parts I have covered already. Where is my public key? I want to show that basically. Here is my public key. This is how your public key looks like. Okay. Even though your private key is there, but your private key will not be displayed, or the owner of the key itself cannot see the private key, because if you give the access to the private key, access in the sense, if you allow the user to see his own private key, then there is a possibility of compromise. Okay. And one more thing, which I feel that it's really, sensible to relate this particular aspect, that in hand signature, you cannot explain to anybody how actually you draw your signature, because the pressure it involves and the spokes in the signature and all those things, the pen up event and the pen down event. Even though if you try to explain, the other person will not be able to take up how much pressure you are applying, how you are drawing. People will imitate the, signature style. They may do the forging of the signature, but by the signature forensic experts, they will be easily identifying which is the original one and which is the forged signature. So, despite the fact that over the period of time, it becomes your, memory, okay, muscle memory, I can say. So, muscle memory, with the muscle memory, you will be able to sign multiple documents, but you will not be able to explain. So, every hand signature is related to some secret we know, but that secret will not be able to share with anybody. So, this particular feature is also imbibed in the digital signature, wherein even though you have a private key, but you are not able to share the private key with anybody. Okay. So, so that the secret with which your signature is created is not being shared. Okay. So here, this is my public key. So I'll just go to the learn.pki.in to explain more about this. Now, this is a demonstration which you can also access on learn.pki.in. So, anything, it can be loss of token, or let us say, if I fear that my keys are, let us say I have kept the keys on my desk and then I'm out of station for a couple of days. So even if I fear that, then also I can submit the complaint to the CA saying that my keys are compromised. Okay. Or there is another reason wherein my office feels that I have done some fraudulent activity with that particular token or with that particular certificate, that also will be revoked. Okay. So all those multiple reasons are there, but here the key compromise is basically the loss of token. Okay. Now let
one more question. Like in MS Word, MS Office, we have option only one signature. We cannot go for multiple signature. Whereas in PDF, you can go one by one, multiple signature. So what happened in the first signature? Initial signature was computed on the hash of the document. Afterwards, another signature, if you are doing that, so it will take only hash of the documents, including the first one signed.
Yes.
Entirely document will be considered as a single document.
Yes.
Then second signature
Yes.
is formed, and so on, third.
Yeah.
and multiple signature.
Content plus signature becomes the input for the next level signature.
But in Word, it is not possible.
Yeah. In Word, multi-level signature, they have not
Because
provided.
only it applies
Yeah.
only.
Yeah. PDF has
unsigned
provided this
document
particular
only
option.
it is
Yes.
signed.
Okay.
But
So
this will be for counter signature only, no, not for parallel.
what do you mean by parallel?
Parallel means multiple people are signing into the same document, but they are not counter signing each other.
No,
I'm trying to understand what is the difference,
counter-
because
counters.
see, in our invoices or in our indents, not invoices, indents, there are 5 people who are signing: the indenter, and then his FLA, then his group head, then the executive director of finance, and all. So one after the other, all the level of signatures are being done.
Yeah, this is actually counter signing.
Okay.
So now parallel signing in means all people are of same level. They are agreeing to something, some note.
So it will also be one by one after the other only, no?
But that's a different.
Actually, in PDF, there
Concept.
is no concept of parallel signing or horizontal signing.
Yeah.
You can say the horizontal signing, but in fact, here submission is not like that, because once after you are signing, first will sign, they will calculate hash on the document part. Next onwards, they will include the signer part also. So it means either parallel or horizontal, it will keep as same.
Even your hand signature will not be parallel, right? Suppose minutes of the meeting, if the committee members are signing, all put together, they will not sign together on a single document, right? One after the other only, the members will sign. So the same is, implemented here.
But in that case, you can see, suppose me and you are parallel signatories. Me, I can also sign before you, you can sign before me. That's the difference where in counter signature, if I am your senior, then you have to sign, then only I'll sign. That's the difference. That's the workflow.
That is the workflow you are talking about.
Counter signing.
Actually, these are the customized signature. Actually,
Yeah.
for parallel signature, mathematically, we can create multiple signature and more than one people can sign. And by using one key, it can be verified who signed that document. Mathematically, it's possible. But it's depend on us whether we want to sign in parallel or not.
But current applications do not provide that. Current applications do not. It's just a matter of workflow.
Like in MCA 21, you are talking about, it will work like that because on first director or co-director will sign. And in hierarchical wise, first it will compute the document hash and then first director will sign. And afterwards, it including the co-directors as well as the next one part also.
Even if you look at the Passport Seva Kendra counters also, what I understand is what they have said is the counter A guys who are mostly TCS people who scan the documents and then they digitally sign that and then they forward it to the counter B. And from counter B onwards, there are MEA officials, Ministry of External Affairs officials. So they again validate that document against your originals. And then once they sign it, it goes to the counter C, which is basically the issuing officer, approving authority. Okay. So that approving authority looks at the previous two signatures as well as its validation. And once it is done, and if based on the whatever terms and conditions, rules and regulations, they will sign it. Okay. So now let us see this as a digital certificate contains a key pair. So here we have taken an example of RSA with 2048. There are two more, sizes that are given here, 3072 and 4096. Let us go with 2048. That is what we use. So when you create it, when you click on generate, it creates a public key and private key. This is just for demo purpose. That is why you are able to see the private key as well here. Okay. So this is public key and private key that is created. Now this public key, private key, once it is created, it has to be kept in a document, electronic document, which is what I was mentioning. So that electronic document is nothing but your digital signature certificate. So click on this. Now that document requires the details of the person because the CA is going to endorse on this document saying that this certificate belongs to so-and-so person. This certificate belongs to Misbah, Anoop or anyone. Okay. So I'll just type here.
सर जैसे काउंटर सिग्नेचर ऐसे ही मेजॉरिटी सिग्नेचर भी हमें बनाना चाहिए. ये सपोज करो ग्रुप में 5 मेंबर्स हैं, उनमें से 3 ने साइन किया है और मैथमेटिकली वो सभी से एक दूसरे से रिलेटेड हैं. वेरिफिकेशन के टाइम हमें सिर्फ एक की चाहिए जो भी तीनों के लिए वैलिड होगी और जस्ट मैथमेटिकली हम जज कर पाएंगे कि किसने साइन किया है. तो एक्चुअली ऐसा मेजॉरिटी सिग्नेचर भी हमें मतलब बनाना चाहिए. मैथमेटिकली पॉसिबल है पर ये कब डिपेंड करता है कि सीसीए वगैरह उनको अप्रूव करते हैं तो वो भी मुझे लगता है कि अच्छा होगा.
There are two more problem statements that are repeatedly coming and then in many of these type of forums. Number one, the defense agencies people, they have said that if I want to share some confidential message or a secret with all my entities across India, okay. So using PKI, how will you do that? Because everyone's, let us say if it is to be encrypted, if it is, confidentiality is required, then obviously I have to take each and every officer's public key, right? So if 100 people are there, then 100 public, separate, individual public keys I have to take. Okay, so once we were delivering a talk in one's defense agency, so there they have given this particular problem statement actually. They said that is it possible that I use as an officer one public key, okay, and send it to individual people. It goes individually to everyone because private key cannot be shared, okay, and everyone uses their own private key for decrypting their respective message. What is the algorithm? It's possible, then it is very good that we can submit a proposal actually.
Yes.
With public key cryptography, with RSA kind of algorithms or some other algorithms are there?
मोर देन वन की को हमें जैसे मॉडल लेते हैं, समझ जैसे तो हमारी मैथमेटिकल इनवर्स हैं, ऐसे ही हम उसमें मोर देन वन मैथमेटिकल इनवर्स लेंगे।
Okay.
ठीक है, तो उस केस में क्या होगा कि सपोज करो 4 की से हमने इनक्रिप्ट किया, तो जो 5वीं की है उसको यूज करोगे तो चारों में से किसी से भी इनक्रिप्ट करना उसको
नहीं, हम 4 की से एनक्रिप्ट नहीं कर रहे हैं, हम एक की से एनक्रिप्ट कर रहे हैं।
ठीक है,
हम एक की से एनक्रिप्ट कर रहे हैं, बट डीक्रिप्ट जो होगा वो n नंबर ऑफ की से डीक्रिप्ट है।
पॉसिबल है, आप जितना चाहोगे जितना चाहोगे उतने से पॉसिबल है।
ओके ओके, कैन यू स्विच ऑन माइक खान साहब?
In Outlook Express or live mail, such arrangements are already going. It is exclusive of arrangements.
Yes,
Live
so
in a group of people.
It's very simple.
जैसे symmetric
हाँ,
based manual,
सब में
anyone can use. It will differ.
No, it is not. It is the requirement is not for symmetric key. Requirement is not for symmetric key.
It's not requirement of symmetric key.
Without
सर मुझे सिर्फ 1 दिन का टाइम दीजिएगा, मैं आपको कल बना के दे दूंगा।
no, no.
इससे इट्स नॉट मतलब इतना टफ नहीं है।
Okay.
Before using the public key, because public key is one part, but at the session level, that symmetric key is being used to decrypt your public key. Because once the public key will run over the other side will definitely decrypt the message. So that's why some session key is involved within that.
जैसे आपका लीस्ट मल्टीप्लिकेटिव इनवर्स है सर।
Once you are using the Outlook Express, then
सर सिंपल ऐसे मान लीजिएगा जो आपका
the multiple recipient.
लीस्ट मल्टीप्लिकेटिव इनवर्स है, ठीक है सर, जो लीस्ट मल्टीप्लिकेटिव इनवर्स है उसके नेक्स्ट जो मल्टीप्लिकेटिव इनवर्स है वो सेकंड की हो गई, थर्ड आपका जो भी इनवर्स है वो नेक्स्ट की हो गई। तो अब उसके बाद क्या होगा, सभी जैसे जी पे पावर ए भी आपने लगाया, ए भी लगा और ए भी दोनों के इनवर्स हैं। अब ए को आप चेंज करते जाओ, मींस ए जो बी के मोर देन वन इनवर्स पॉसिबल है, ए आप यहाँ पर लीस्ट मल्टीपल इनवर्स ले रहे हैं, नेक्स्ट आप यूज कर लो, फिर आप नेक्स्ट यूज कर लो, लेकिन फाइनली आप मोड लेंगे वैल्यू सेम है।
साइनिंग की बात नहीं हो रही, साइनिंग ऑलवेज वर्क ऑन
Correct,
वन
sir.
टू वन।
करेक्ट सर, एक बार आप साइन करो, एक बार साइन करो,
वर्क लाइक एक्सक्लूसिव और विल वर्क बिकॉज़ आई हैव ऑलरेडी
राइट। तो सर जैसे सपोज आपका
हाँ,
That of logic.
क्योंकि मैंने क्या किया कि एक अपने पब्लिक
Asymmetric key is there.
है ना, मैंने पब्लिक की से साइन किया, साइन एनक्रिप्ट किया डॉक्यूमेंट, अब मल्टीपल
सर सपोज एक हमारी पब्लिक की बी है
हाँ।
और हमारी प्राइवेट की है A1 A2 डॉट A10, ठीक है। अब A1 इंटू बी, जी पर पावर A1 इंटू बी मॉड एन करेंगे, सेम वैल्यू आएगी A1 इंटू A2 इंटू बी मॉड एन। तो आप जो भी आप करते जाओगे A1 इंटू बी, A2 इंटू बी, A3 इंटू बी, क्योंकि A1 A2 A3 सभी एक क्या है मल्टीप्लिकेटिव इनवर्स है बी की।
नहीं, जैसे मैं बता रहा हूँ कि जैसे 5 लोगों को हम डॉक्यूमेंट इंक्रिप्ट करके देंगे,
करेक्ट सर।
तो 5 की पब्लिक की हमारे पास होगी ना, तो उस पब्लिक की के बेसिस पर एक्सक्लूसिव और करके हम निकालते हैं एक सर्टेन की, वो की आप अगर पब्लिक की वहाँ लगाइएगा प्राइवेट की, तो वो भी डिक्रिप्ट हो जाएगी।
सर अभी हमें क्या है कि जो इंडिविजुअल हमें पेयर नहीं लेना है, इंडिविजुअल पेयर नहीं लेना है। नो सर उस केस में काम नहीं करेगा ये इंडिविजुअल पेयर लोगे तो काम नहीं करेगा ये।
But it will not be called as public key, private key. It will not be called as public key, private key.
In our logic, we are using SHA 256 algorithm where their logic is not perfect.
हाँ मैथमेटिकल पॉसिबल है।
Implementation if we talk about public and private key, it has to be restricted to one end, it has to be separate.
Correct.
Doesn't mean that he keep on encrypting at one end, finally he gets one public key, gets decrypted. No.
No, I am talking, I want to understand what encrypted mail to multiple people.
Correct.
over the email,
राइट,
how it works, because individual people have individual private key, and that's why the mail goes to the different people, they will open by using
सर
their
उस केस में सर वहाँ पर नहीं सर पब्लिक की सर एक है, यहाँ पर पब्लिक की एक और प्राइवेट की 10 है। अब ऐसा
Sir, sir, I have one request. Let us make our lunch more interesting. Okay, and it is really good. Let us give a big round of applause for all these, because all of them are actually from the mathematics background. Okay, and mathematics plus cryptography, so they have very killing background. Even if you look at Dr. Ompal, Khan Saab, and Dr. Pandian, so they have done a lot of work in these algorithm areas. So I'll come back to the basic level again, to my level, in fact. So, no, this is a good thing. I think we'll take this discussion forward and try to do something for that, because defense agencies have earlier also, when I presented a couple of years back and recently also, they gave the same requirement. Surely we will look into this particular aspect. Okay, sir. So again, going back to the certificate part, already whatever technology we have just, you have just seen that in the previous screen. I have created the public key, private key, and now the digital certificate will be generated here. So now when you click on generate, your digital certificate is created here. Okay. This is the actual process, step-by-step process that happens in the digital signing, whereas it looks very simple when you implement it using, I mean, in an Acrobat or in MS Word. Now I download this certificate. So somewhere this certificate has got downloaded. So it is created in .crt format. Okay. Since this is a self-signed certificate demo, that is why issued to Misbahuddin and issued by Misbahuddin. And my original certificate, which I have shown you, I used for the demo, this is issued by CCA, and this only CCA certificate will be the self-signed certificate. So here this is created for 1 year duration, and then all the details are given here. So I'll just proceed further. So we now have public key, we now have private key, we have the digital certificate as well. So let us try to digitally sign any document. Okay. So I'm just typing a message called, this is demo of digital signature. So what happens actually? As I told you, it's a two-step process. The first step is the hash value will be computed out of this. So when I click on this, now it is asking me which hash function I want to use. Let me use 512. So generate message digest. So now this is the message digest that is created for this content that I have given in the previous screen. Okay. So what happens now? The next step is this particular message digest will be encrypted with the private key. Okay. So basically in the crypto token point of view, the message digest goes into the crypto token, and then there it gets encrypted after activating the key when I enter the my PIN or password of the key. So here, this is the private key and this is the digital signature. So sorry, a message digest. This message digest will be encrypted with this key. Okay. So private key of signer, which is Misbahuddin. So I'll click on generate digital signature. So my digital signature is this particular value. This is the value which keeps changing based on the change in the content. Once I change the content, the message digest will change. And since the change message digest is there, the resultant value of the digital signature will also change here. Okay, let us see that now. Now digital signature is created. Once the digital signature is created, this digitally signed document goes to the receiver, and receiver wants to verify the digital signature. So let us try to see the verification here. Now in your document, you have earlier in your document, Word or PDF document, it was only the content or the text that was there. For example, only this part was there. Later on, once you had digitally signed, now you have got digital signature attached to the document as well as the public key of the signer attached to the document. Okay. Now, at the verifier side, now verifier wants to check two things. Number one, whether the content is modified or not. Okay. So basically, it is a digital signature verification. And the second one is whether the digital certificate that is used, this certificate was valid or not at the time of signing. So these are the two different types of verification that happens. One is the verification of the digital signature. Second one is the verification of the digital signature certificate. Generally, many of the people get confused if they hear first time. See, digital signature is a signing process. It's a technology which follows a process, two-step process, which I told you. Whereas digital signature certificate, The moment term certificate comes, that means it's just an electronic document which has your key. Okay. So these two generally people get confused because both are starting with digital signature. One is digital signature, another one is digital signature certificate. Certificate means document, signature means it's a process. So for verification, sorry. Now this digital signature is actually the encryption of the message digest of this content. Okay, message digest of this content. So what is to be done? This is the encryption using private key. So the decryption is to be done using public key. Now, where is the public key? Public key is already attached with the document. Okay. And anyone can verify this document. Anyone, even the, criminal or cyber criminal, if he also gets this particular document, he will be able to do that because there is no additional confidentiality feature provided on this document as of now. As I told you in the beginning, the digital signature provides you AIN, authenticity, integrity, and non-repudiation only. So let us try to verify this. I click on this. It says what it does basically in the process is first the system takes the content, computes the hash value. This is on one hand. Another hand, this digital signature is decrypted using this public key. Once you decrypt, again you get the message digest. So the message digest just now computed and the message digest which is decrypted from this. So here it is, decrypted digital signature and the message digest of received message. Now both are checked. If both are same, if both matches, then your signature is valid. Let me try to add a full stop. Okay. And click on verification. So what will happen? Basically, this message digest will change. And since the message, there is a change in the message digest, this will not match and the digital signature verification will fail. Okay. Verification fails here. Okay. So this is what is the digital signature verification. Now, when it comes to digital signature certificate verification, so there are 5 parameters that generally it looks at. Number 1 is who has signed this, whether that CA is valid or not. Okay. So as I shown you in the demo, eMudhra has provided the certificate. It's a licensed CA. Okay. So that is one. Number 2 is trust. What do you mean by trust? Up to root level. Okay. Here, if you look at in my document, the trust, it is deriving the trust from the CCA, the root certificate. Okay. And every certificate it is showing okay. That means it is a valid certificate. Okay. Otherwise, it will give an error message. Okay. All the certificates in this chain are valid. So in the certificate chain, going back till the root level, that is called as trust. Okay. That is the second point. Third point is public key. Okay. What is the size of public key basically? It is 2048. So that it checks. Okay. And apart from that, certificate revocation list. Now, while validating this digital signature certificate, it checks the serial number with eMudhra CRL, which I showed you. Okay. Whether this serial number is present in the CRL. If it is present, then that means there is a doubt now. Now you have to look at the timing of the signature and look at the time at which the certificate is revoked. Okay. Let us say 11:30 or 12 o'clock I signed, 12:30 or 12:45 I lost the document, and post 12:30 you received a document with a digital signature, with my signature. So the CRL is showing that this particular certificate was revoked at 1 o'clock and you received a digitally signed document which was signed at 1:30. So obviously you should not accept it. You should not basically consider that as a valid document and then call the person and follow the process. So that is the fourth one. Okay. So trust, and then the expiry, time expiry. Okay. Whether the time validity is still there in the certificate or not. So these are the 5 parameters which are being checked whenever the certificate is digital certificate is used. So these are 2 most important aspects whenever you digitally sign a document on the digital signature verification end. So one is the digital signature validation, which is through hash process. Okay. So basically that tells you whether the integrity is breached or not. Okay. And the second one is the digital signature, the certificate validation. So one is signature validation, second one is certificate validation. Signature validation is a two-step process. Certificate validation is about 5 parameters. Okay. Generally, whenever we are signing, when I'm connected to internet, it is checking the validity of the certificate first.
You do the CRL
Yes, verification, and then
you
allowing me.
apply the
Yeah.
signature on the
Yeah.
data. Then only you'll ask me to apply the signature on the paper. Yes, that's what. It will be somebody does the first they do the signature and then they say that after that it sees that it the certificate is.
It totally depends upon DPI.
What, sir? Ram sir, can I ask? I have one doubt because different CAs we have spoken to. Okay. So the thing is, based on their certificate, policy, they are saying that the CRL updation time, 12 o'clock, if I lost my certificate, loss of token or something, and I reported within 15 minutes or 20 minutes, then whenever their business hour comes, at that time it will be updated, or immediately after loss, they will update the CRL.
hours.
72 hours. But what that 72 hours the person should do?
Yeah, OCSP and OCBSP.
But OCSP is not there, no? Only. But central OCSP is yet to come. Centralized. Every CA is having, but centralized.
Centralized OCSP response is coming from the CCA side, ocbs.gov.in.
Even in CRL distribution point is there, in the same manner, OCSP point is there in your certificate. Once you are doing the business or transaction by using digital certificates, now it first go to the sites, OCSP, ask whether certificate's condition what it is good, then it will allow, otherwise it will not.
Okay.
Maintained by CA.
Okay, sir. So, any questions or anything, or we'll go to the next one? The next presentation. Balaji, you are taking? Ram sir, request you to kindly.
Online.
You have your laptop or something?
Misbaji, just one question, if I can ask. Actually, I think you answered this thing. See, what happens to the validity of the issuer if it is, how to recertification, how does it take place when the validity of the issuer is gone? So, yeah. So whether that responsibility lies with the issuer, because
Yes.
if I am the user, then you told some this token has to be inserted. So how do I know? So I have to check or
No, eMudra told me, in my case, eMudra told me, I asked them whether should I send a reminder to you or what is that? Because I need to keep track unnecessarily,
But
right?
that
I have
is-
taken for
that
3
is
years. So they
wrong.
said that,
See, if
No.
eMudra gives a certificate and his issues a certificate today and tomorrow that certificate is invalid. So that becomes then basically the trigger should come from the issuer side.
that is what they said to me. That is what they said to me, that it will be seamless. Let me see, it's just 4 days left for that. No, not 4 days, tomorrow. 5th, eh?
Or if there are, your certificate is going to expire within 3 months before.
Excuse me, sir. I represent eMudra.
Yeah.
So from a business angle, I will just tell you.
Yeah.
Maybe from a certificate perspective, as a regulatory practice, we are actually supposed to intimate the subscribers well in advance. So we actually do that 30 days, 15 days before the expiry of the certificate to make sure that the certificate need to be renewed by the subscriber himself. So once that is being performed, So it is up the responsibility of the subscriber to do the regulate the process and get the certificate renewed. Okay. So it's, in case if he actually forgets or something, then the business continuity lost because he may be not able to use it in the application, say example MC or something. So let's say if the certificate is being issued a day before the expiry, you can actually go ideally to the respective application and update your new certificate with the old one. So that this provision has actually been done by various applications, including income tax or MCA or a lot of other GSTN or other tender portals and other things. So that functionality, which application will be calling it as a re-registering of your certificate, new certificate. This is normally a business process which will happen. From a subscriber angle, you need to get the certificate because will be intimation will be sent to you. As the sir was actually mentioning, it will be sent to him and he can actually have the process of getting the certificate renewed.
And from the public, it's not my question, public question. Will I be charged again?
Yeah, yes, because
Yeah,
ideally.
No, I have taken for 3 years, right?
Yeah. No, if it is 3 years, it's a business call. If it has been issued for 2 years, then you will be automatically get the certificate for the other one also, because that is a commercial aspect of
Yes.
it, that you will be automatically getting one more year of certificate. Now, if it is coming as a, let's say if a certificate is issued for 2 years, it is already getting expired and you need to renew it, then it will be charged commercially as per a new certificate.
One more question is for, let us say, for a student community or for example, startups, and because government is also, because this question I have got in some event, government is also supporting startups a lot and all. So what the CAs can they offer without charging the certificates for them to test their applications?
Yeah.
Is that kind of option is there with CAs?
Yeah, so there are things are available because that is the way where CCA has actually created a class of certificate called as earlier it was called as class 1 certificate,
yeah,
which is only used for the demo purpose. Currently, it has been discontinued commercially by other CAs because they are. But eMudra has a provision to issue class certificate. This is basically for specifically for any testing purpose or something. Normal certificate itself, like class 3 itself, can be issued free of cost based upon the business case. So that is not an issue, but this provision exists.
Then what will be the validity of that certificate?
It will be issued for ideally for the normal year only, 1 year, 2 years, like that. They can actually test it out, but there are provisions to be restricted to 6 months also, or maybe with a shorter validity period in case it is required.
One important question related to the legal validity of that. What will be the legal validity? Because we are issuing it for free.
Yeah.
And will it be legally valid, or will it be just called as a test certificate?
No. It is normally if it is coming under the normal route of let's say in case eMudra, it will be treated as a normal legal valid certificate only. Okay, but if it is being treated like a separate, we have a additional route also, like a demo certificate route. In that case, it will not come under the legal ambit, but the both are available. Let's say if they require just for the testing purpose, we can issue it from our test route itself, which will not have a legal validity. But if in case some other applications like a defense application or government application requires that legal validity, that also can be provided.
Okay, thank you very much.
One more point from the subscriber perspective, if they purchase a certificate and already if they have a valid certificate in their token, they can delete that certificate which is existing in the token, and then they can actually start using this new certificate. So that way the applications also will be easier to detect the certificate, the newer certificate. So this is one point just from the user perspective I wanted to share.
Otherwise, you can use multiple certificates under the token for testing purpose.
Testing, yes, but as a regular user, if you want to avoid the confusion, that older certificate can be deleted, and
scenario you cannot delete because once you have earlier used in the tender process, So your certificate or private certificate need to use for future reference also.
Sir, I think key code of facilities.
No,
at level.
no. See, what we meant by certificate here is basically you can export the certificate and certificate will have that public key alone can be there. But this from the
Only-
token you can delete.
No, for signature purpose, it's okay.
Yeah,
The
signature.
signature is okay.
Yeah.
But once you have taken encryption certificate, like you have used on CPP
Yeah,
portal,
encryption certificate, yes.
CPP
you have
portal,
to.
then you need to have that private key also for decrypt the
Absolutely.
tenders, which will happen after 6 or 4 5 months.
Absolutely, I agree. sir.
That
That's
are
a-
having the problem.
Yeah. that
So
is-
I think PFX having, sorry, encryption certificate having PFX file, you should keep that as a backup. Because in this case, if your token will lost or the misconduct.
I think,
Just now, let us see.
yeah. So now I invite Mr. Ramchandran from Office of CCA, he's scientist F, and I think he has immense knowledge because he has been associated with the Office of CCA since its establishment. So I welcome you, sir, and we are eagerly waiting for the presentation, which will be rich with all the, I mean, important aspects of basically from the policy point of view and all that.
Yeah, good afternoon, everybody. I'm Ramchandran from Office of CCA. So basically, majority of the things I'm planning to talk about the certificates, and some of them it is already covered by the MISPA. So my task is very less now at present. In this forum, I just want to know how many of you are from that developing or managing background. Can you just raise your hands? Okay. So this presentation basically tell about what are the certificates usage, how to use the certificate in the application, and encryption certificate, how we should handle at organization level, and some of them, as I told you, Misbah has already covered. So I'll not be repeating that one. I'll skip that slides.
No, so it is low actually.
No, this how to go to next. This only. So I'll start with the Information Technology Act. As you know that Information Technology Act was enacted in 2000. Under that CCA, under the provisions of IT Act, CCA, Office of CCA established controller license and certify the public keys of the CAs. And there are around 22 certifying authorities in India as of today. So basically this CCA has two functions. One is that licensing, second one is that certifying the public keys of the CAs. So under licensing, they used to see what are the financial aspect and technological aspects of the authorities. And once it is satisfied, then we will give approval for the CA. And this CAs, once it becomes CA, then their public key will be certified, and this CAs further they can create a issue and user certificate. These are the hierarchical model which followed in India. So as you can see, root CA is at the top. It is a trust anchor of the entire hierarchy. We will say trust anchor because it is a self-signed CA. So all these certificates issued at lower level, that verification will stop at root CA level because it is a self-signed. And this certificate, as of today, it has been included in the Adobe as well as in the Microsoft product. So you need not to see, means if you are using Adobe, you will get automatically, you can see that certificate in the Adobe Trust Store. So we'll come to that CA service. Basically, CAs are providing services like issuance of DSC to end users. And also CAs are providing certificate status service, because this CRL, they are supposed to make available all the time. And now it is mandatory for all the CAs to provide a OCSP service to applications. So any application, if they want to check that their status of their subscriber certificate, they can call the OCSP service of the CA. It is already present in the end user certificate. There is no need of going to find out where is that this one. So in the end user certificate, that CRL of the CRL location, OCSP location, and certificate issuer certificate location is already present. In a standard tool, like it will automatically fetch this OCSP or CRL from the CA side. So, and other one is that e-sign, which is not covering in this particular presentation, and timestamping is the another service which are provided by the CAs. As of today, all the CAs are having this timestamping facility, but only one CA is publicly providing. That's what as per our survey from the CAs. And one more aspect which we already covered, this when a CA issue a certificate to user, this certificate normally valid for 1 or 2 years. During that period, if a user forget his token, forget his password or misplace, or at least one time, CAs are liable to issue a certificate at a free of cost. So you can, it is given as a guidelines from our office. So in case if you are not getting this one, you can always contact our office for this purpose. Because that in that case, if time taken depends on you have to contact CA for that this one, and you have to prove your identity, same identity as a same person, because somebody else should not be claim that particular certificate. So normally that one video verification is a requirement. If you are available immediately, then you'll get a certificate as soon as possible, and token also should be with you. Normally the issuance now, earlier it was a paper based issuance, now it has mostly switched over to completely electronic mode. So that way normal time for issuance of certificate is to 2-3 hours only, because that for issuance of certificate they CA need to verify their name, address, phone number, email, all this happens very fast. And also for the physical verification purpose, they used to do video verification for a 30 seconds. And if the video verification is not there, you can provide online Aadhaar authentication also. That also treated as a equivalent to physical verification. So normal certificates are validities 1 to 3 years. E-sign certificates which are not covering in the 30 minutes validity. And to get a certificate from CA, you have to that subscriber has to undergo a verification process, as I mentioned, name, address, email, and PAN number. At least one ID is important, like either PAN number or last Aadhaar number. In the case of Aadhaar number, they used to see that last 4 digits of the Aadhaar number, and that will be a part of the certificate also. What advantage of this one is that if an application, they can always cross verify whether this is the same person or not, because if they have a PAN number of that particular person and the certificate issued to that person also, if that PAN is matching, then they can reasonably assume that this is the same person. Or if they have a Aadhaar number, last 4 digit of the Aadhaar number, it can be assumed as a same person. So that purpose, at least one ID, PAN number or last 4 digit of the Aadhaar number should be a part of the number. And also this mobile number also part of this. So if you are checking that possession of the mobile with the subscriber, that point also you can confirm that whether this is the person or not. Certificates are all issued to foreign national also, it has been issued. The similar way it has been issued to our subscribers. And coming to the different type of certificates, that is, certificates are issued for a personal purpose, organizational purpose, and this difference between that personal certificate, personal use and organizational use is only difference of the address within the certificate. If a person apply with on the behalf of means with a address proof as a his own house address, then he'll get a personal certificate. Or but if you apply on the behalf means with the address of organization, then certificate will contain that organizational but organizational address in that verification is little bit more. That CA will examine, check whether that existence of the organization, whether organization whatever you are mentioning is true or not. And the process has been defined in they are following, and also that that one person from the organization should certify that this person belongs to this organization, and that part is also so. Though for organizational certificate issuance, verification part is a little bit more. And system certificate and time stamping certificate. The time stamping certificate is used by only CS, and code signing certificate and OCSP responder certificate is also used by only CA. Encryption certificate. These are issued to an organizational person only, not for an individual. Means as a person, it will not be issued. So only for the organizational user, this will be issued. And document signer certificate also issued to organizational use. SSL certificate also issued by some of the CAs. And that coming to the class of the certificate, there are different class has been mentioned. Application can opt for a different class of certificate. All type of signatures are legally valid. Still, they can, if they depending on the type of usage, like if they want to use the token for this one, they can opt for a class 3 certificate. Earlier, class 2 also there for a individual signing certificate. Now class 2 has been eliminated because class 2 was that class 3 that physical verification is a mandatory. So we made that physical verification mandatory for the class 3 also. So there is no class 2 individual signing certificate, only class 3 exists. Legal sorry?
Machine certificate is same.
System certificate are for the technology purpose only. There is no legal validity involved in that. Only thing is that you can always say that it has been issued by from a trusted source like CA, certifying authorities.
But no legal validity.
Legal validity as per the IT Act definition, it has given equivalency only to the replacement of ink signature. So that is if a person apply ink signature and if you are applying a digital signature, that legal validity. Otherwise, because many people are using, because but the trusted source is one of the important thing. Because if your organization themselves run a internal CA, enterprise CA, the trust on that one is not so I don't know. You have to prove that one, how you are securing that one, how many people are involving in that. But here it is an established system like CA system. So you can always say this certificate has been issued after a verification. You can always use that one, that way. And legal validity of the certificate. Legal validity of the certificate is mentioned in the IT Act. That it has two aspects. One is that it is coming, that certificate which you are getting, it should be issued by a certifying authority. That is one of the aspects. Second one is that how you are applying a signature. What are the procedure to follow for applying signature? So these two aspects are satisfying. Then it can be said that it is a legally valid signature. But as per the section 5 of the IT Act, what it is saying that a subscriber should apply the digital signature as per the manner which is mentioned in the rules. And the rules which is mentioned is the identity digital signature rules. There it has mentioned that creation of signature, validation of signature, because whatever Ms. Bas already mentioned, the same only. It is a hashing using a private hashing and encrypting using a private key and verification using a private public key kind of thing. So this, if it is followed, then it will be legally valid. And the normal certificate, signature, there are two types, or basically categorized. We can categorize. One is that basic type and one is the extended type. In the basic type, it is a signature plus that signage certificate should be a part of that one. So if in a if you see a document, if you are signing, normally we write our own name also. So same should be replicated in the electronic world also. So if you are that signature should contain signature as well as the certificate of that person. So and extended signature, I am coming to the next this one, so we'll cover there. And certificate validation, certificate should be valid at that point of time. That is very important, and it should not be revoked. And also, and that certificate has some fields like key usage, digital signature non-repudiation should be a part of that certificate. Otherwise, and what we observed is that in some of the application, major application, it is allowing to register the encryption certificate also in the application. So technically, it is possible to sign using that encryption certificate also. But that since the application lacks that check in their this one, it was accepting that one. Those kind of mistakes you should avoid in this. These are the and revocation information. And in the extended certificate, anyway, I am coming to that one. Extended certificate, extended signature format, that not only the signature issuer certificate, apart from that, this one, all the issuer certificate like sub CA, CA and root CA and their certificate as well as their CRL information should be a part of that one. So then for a relying party, if they want to verify that one, then there is no need of making an external code. Everything is within that certificate, signature itself. So in the PDF, in the eSign service, it has already mandated if you are getting a eSign, as Ms. has already shown you that some certificate with all the certificate in that chain, that those kind of this one. Apart from that certificate, that CRL information also should be a part of the signature. Yeah, that's whatever already mentioned. Details required for the revocation should be a part of this signature. And nowadays, earlier that only CRLs were available. Now all the CAs are providing the OCSP service. So OCSP service, if you request for a OCSP, it is not more than a 200 milliseconds, less than a 1 second, less than a 1 second always. Very rarely I found that more than 1 second. So it is so basically what normally that what application used to do is that if they have a frequent verification requirement, if it is a within application, there are two types. One is that if signing and verification is managing within the application, then you can keep all the verification information in a single place. But if the signature verification requirement is external to the application, like if you are signing a document and publishing it on your website as a PDF, this one, that is an external one. Many people will download it and check whether the signature is okay or not. If you see that income tax site, one digitally signed document, if you upload that one, lakhs of people download it and verify whether, check. Once they open that one, it will automatically check the signature of that one. But if the signature does not contain that all the certificates and CRL, this one, all that Adobe will send a request for the respective CA to get their CRL or all this. So many means much communication will take. You can avoid all this kind of thing. If you are developing an application, if there is an external verification required, it is better to include all the verification information within the certificate itself, so that all this communication related can be reduced. And in that at organization level, there should be a procedure in place. If organization is using that digital signature certificate, and organization also should have that record of that. If the person is not available, or if they are transferred anyway, we can get it. But if he is not available, at least organization should be able to request CA for the revocation. So in that sense, we have to get at least the minimum information required, like serial number, name of the person, and when it has been issued. All this kind of thing should be kept at organization level also, so that in the absence of that particular person, that organization can request for a revocation of that particular certificate. Organization should not mandate transfer of digital signature key certificate to any other person. It has already happened in some of the organizations. That's why I'm just pointing it out. Even if you are in your organization, you should not do that one, because it is signing is a very much attached to that particular person only. But organization level, there should not be any mandate for using other signature key in their application. And if you are an application owner, before at the time of planning this one, you should take care of what are the where we are going to use this digital signatures. So they like operating system. If it is require a support for the operating system, different operating system, whether the signature will support, token will support, all this kind of thing at the initial level itself, you should be taken care of. And the recommendation for that application is that in some application we earlier found that it start with the usage of digital signature certificate. Once you insert, then only it's login also. That is okay. One-factor authentication it can be, but ideally it should be a two-factor. Means this digital signature certificate should be used within the application for the signing purpose. So their application normal that case application should have a two-factor authentication. Once it is get into that application level, then for signing purpose they can use that this one token. And also in some cases where if your application, this is a case a specific case, if some of the application like their uses are very occasional, like once in a month or once in a 6 months kind of, and that is all that may be critical also. So those kind of scenario, it is better to send a SMS or email at the time of signature itself. So even if your application is very critical and if the finance or something is involved, and it is better to use SMS based notification for each signature to user also. And identity of the system. This is just like a Google or any other application. If you are using in some system, and if you are changing frequently, then it will not ask again that user and password. And if you are changing that system to some other system, it will ask for again ask you to authenticate mobile number. All this some kind of system binding to that particular system, that will be helpful for preventing frauds. And time, in respect of time, all the applications are supposed to, in government, all the are supposed to get use the national source of time. If your application is not using the local time, and there is a chance of local time deviation from that, so if it is a major application or this one, it is better to get a national source of time to your organization, and using it should be used. And applications, once it's developed, normally that application develop and it will go on production without any verification. That create a lot of issues. So at least from your side, it should go for a security testing, and then only it should deploy for the production side. Root certificate, it is already mentioned, it is available on the website of the CCA. It can be, there are two certificates. One is that 2014, it is that is expiring on the March 5, and further only one certificate will be there. And if you are in some of the application, they are storing their certificate locally, root certificate locally. Again, instead of going fetching that root certificate from this website of CCA, they store locally, and further verification carried out. But in that case, that there should be a some authorization. That person who is storing that certificate, only that limited person should be have access, because that store, if you include one more root certificate, there is a possibility of chance. You may means even application owner may not be knowing that some frauds are happening. So CA certificates are available on the website of CCA as well as on the website of CCA, but it is available on the subscriber certificate on authority information access, that CA, that link to that certificate is available. CRL information is also part of the end user certificate. There is no need of looking at externally. It will be available on your end user certificate. For revocation information check, as earlier mentioned, there are two methods. One is that CRL, one is OCSP. Earlier we were using that now also using CRL, but it is preferred to use OCSP response because it is that size of that OCSP response is below 2K. But if you are downloading that CRL and using for the signature, especially that end user certificate, that goes up to 200K, 400K. So if you are including that CRL information, the signature, the size of the signature will go up. So to avoid that one, it is better to use only OCSP service, OCSP response as a part of certificate. If you are using CRL, it should be download periodically from that website of respective CA. CA every 24 hours they publish the CRL, and CCA it is every 30 days they used to, and frequently that the chances of CA revocation and this one is very less. So in because if it is there, then normally they used to CA used to notify the subscribers. So you can rely upon that particular thing. In OCSP, this also the OCSP response can be obtained from that CA subscriber level, sub-CA level, CA level. So this OCSP response which you are getting will have a validity of 6 hours. It can be locally stored, and 6 hours without any further fetching of that one, you can use it. So that your application need not to make a external frequent call to CAs, that can be eliminated from this one. And as I mentioned, the OCSP part is it should be locally available. And registration of one of the recommended practice is that any application, that user should have a registration first. Yeah, at that point of time, their validity should be checked. And also key usage part. As I mentioned earlier, though CS will issue only digital signature and non-repetition, that application also should check whether it is present it or not, because that those kind of scenario like encryption certificate should not accepted in the application, and validity period, whether their CS are valid or not. All this chain up to root and their revocation information should be checked, and then only it should accept. Also, one more additional thing is that testing the certificate, whether that corresponding, if your public certificate is contained the public key, so whether the person subscriber claimer whoever is claiming that this is my certificate, whether he possesses that private key corresponding to that or not, that also should be checked. That can be easily carried out using a challenge response. This one, send a signed response from user to application. If application is able to verify that particular text, then it can be reasonably assumed that he is in possession of that particular private key. And the time is also very important. Means this in some cases that there is a litigation that whether it has been registered properly after a checking or not. For the to safeguard application, this one you can keep the revocation, all this information at the application level also. So signature format that I already covered, it is a basic and extended. This one extended format, all the information should be present. Signature creation includes that this is also already covered. Signing, encryption, all the certificates should be a part of that one. And in one case, a very interesting case, that signature creation, you should follow that whatever practice mentioned in the identity rules. There is a normally it is signing and taking a hash and encrypting only. In one of the application, what we observed is that they applied 2 times hash. So then they applied twice hash. That means it was very difficult to verify from an external point of view. So those kind of things should be avoided for the interoperability point of view. Crypto tokens, it is also already covered. It is mandated that you should use an crypto tokens for the storage of creation and key generation and storage of this one. And one point of check you have to ensure is that replacement of DSCs. If it is already registered user, and while changing that certificate to different user, that point of time should be extra careful, but there is a chances of fraud. It has already happened in some cases. So this coming to that two terms, long-term validation and long-term archival, it is if the signature contain all the verification information, then it can be verified for a long time. And the difference is that in the archival, this one, it is additionally that timestamp also will be applied. So over a period of time, if the signature key, strength of the signature key deteriorate, then this over and above the timestamping key, which has a much higher key, that will protect the algorithm within that signature. So it will be you can rely on that particular signature or archive signature for a longer period. PDF required, it is already covered. If it is all signatures are all verification information is covered in the is a part of the signature, then it will not make an external call. That is a recommendation. We are asking all the ministry to follow this LTV format, because many of times it doesn't show the tick mark on that one. The basic reason is that all the verification information is not a part of that one, and they PDF may or may not, depending on that type of this one used, it may or may not make a call to CA, because it has we can disable automatic. So then it will always show cross mark. And to avoid all this one, it is better to include all the information within the signature. So it will be without any effort that relying party can easily see the status of the document. So encryption certificate, again, already mentioned this one. Encryption certificates, it is a little bit of different from that signing certificate. Signing certificate, key generation is happening on that token, but here it is happening at the CA level or system side. Basically, this is done to keep a copy of that one. In many tenders, what we observed is that this after issuance of the certificate, encryption certificate and usage, this token itself is lost or it is not traceable kind of this. So, and their tender is they are not able to proceed with that tender. So in that case, those kind of scenario, this key will be available on the CA, and you should subscriber also should keep a copy of that one. This is the recommendation from our side. And CA to get that encryption certificate and keep key from the CA, again you have to give a validation to CA. Like CA will verify whether you are the genuine user or not. So they will ask you to provide a video verification. If it succeeds, then they will allow you to download the encryption certificate. So what from 2020 January onwards, CA's escrow encryption key that it has started from 2020 onwards. So you can always ask any CA if it is missed, or that they will provide you this one. Audit of the, it is a recommendation from our side that application should be developing a signature enabled application is not enough. It should undergo an audit after that one to check whether you have properly implemented or not. So without that one, that will give a what do you call confidence to that even application on all our application is genuine. It is work as per the requirement under the IT Act. So eSign based, it is not covering in this particular this one. Thank you very much for this. Yeah. Yes, please.
Actually allowed in the any application.
Cash. Okay. No. Private key means, see, digital signature, if a person means having a signing certificate, signing key pair, it is not allowed outside the token. It will generate on the token. It will, if token is not lost, then they can easily obtain one more signature, because there is no risk in that one. But in the case of encryption, that is a different. Once you applied that one, then the same key is required for that.
Sender has to the token, it should get, I should ask for the PIN. Do you need to say that 100 times I should enter the PIN?
A PIN part, that is.
Whenever I send the hash to the.
Acha, you are asking about the PIN.
Ask for a PIN.
That we have defined some session time for that, 10 minutes or something in that.
See, that means I can have a 10 minutes of a time for doing that particular operation. I should not ask for that. for
Yes.
particular 10 minutes.
We have defined some few seconds in that IVG, in that licensing, or somewhere it has mentioned.
The second question, sir, in the Microsoft, we are using the key storage providers and everything. Because from there we get the certificate details and everything of the tokens and everything. Is it like mandatory to go for CNG or CAPI?
That part I may not be able to answer, because it is a too much tech. I mean, we are not involving in that development as of now. So you can check with any of that development team. Even you can ask Viju for that one. They will be able to help you.
Okay.
Actually, you can use CNV keypad, and if you are doing with the signature, the PKCS 7 signature detached or attachment, you can use it.
Because in the, if you go for Microsoft key storage process, then there will be having a key storage in the Microsoft section.
Yes.
What they say is that it will be password protected. Both private key and public key will be present.
Yes.
Do you mean to say that my private key reference will be there inside the inside the key store?
Yes. Microsoft having its own key store called the CERT MDR, CERT Manager.
Okay.
So they have option to save your certificate details under their key store with your private key.
So you mean to say my tokens private key will be?
No, I'm not talking about the tokens case. They are only fetching as a cache memory through the PKCS 11 library. All token having PKCS 11 library, they are fetching token details from first. They are act like a library as an intermediate for your token. They are calling to that concern library and then fetching details from your token.
Yeah, you mean.
But the 11 level is the.
Yes. Yeah. 12. Actually, they are talking about only token case.
That is where my confusion is, like we say that wherever we say that private key never comes out of the token.
Yes.
It's very good, fine. It's a good concept and okay. But when we are saying to go for a Microsoft key storage and a key store provider and everything,
I think
they have a container, key container. They have a key container. Inside it, they will be having a key container. In the key container, both, if you see wherever you see Java key container, Java key, both wherever you see, they talk about the both private key and private.
Yeah, I got your point. Don't confuse about the PFX based certificate and token based certificate.
Okay.
Actually,
that's what most of the token providers, whenever I say that I put my token.
Yeah.
My key, whether if I generated the token inside, keeper generated inside the token, I agree that the private key generated inside and only the public key comes out. But in case, wherever there's some case where I get the PFX files and it is asked to store it inside the token, then my private key comes out, right?
Yeah, if you stored in the Windows store, key store or the Java based key store, Java is also providing various key store like JKS and other key store. So you can store there. But sir has explained about the token based certificate. In the token based certificate, you will access through the DLL file, which is called the SDK, commonly called the SDK. So in that case, you should send a request, like you should send a hash or of each operation.
Yeah, that's what, in the demo also, in the PDF also, you see there was a digital ID.
I would,
Digital ID was generated inside the Microsoft, only from where the digital ID, the tokens, certificates were being.
But at the time of signing.
I would
you are
like to
signing the
interrupt.
hash-
It's anyway lunchtime, so we can have sit on table, have lunch and discuss in detail.
But I think it is both types of handlers is there. One is the including private key, which is the only soft token based. It will be exportable into the any key store as well as without private key. What you are talking about the private including private key, na?
No,
So-
not without, because my token is having private key, so I'm talking about what is the key store provider I have to use in the Microsoft. So
In that case, only your reference will be go inside the Microsoft key store. Only your private key, public key as well as your certificate will go inside that. Rest of the part will be over your token. Once you sign, it will ask token pin. That's all. Only the difference is like that.
In layman language, you can say that Microsoft act like only Explorer, not act like TS4.
Thank
Where
you.
your private key resides, it will ask pin of that. Either it may be the store or it may be on dongle.
whenever my document is there, it will ask.
Yeah.
Yes.
Thank you. Thank you. Now I will request Dr. Balaji to felicitate our speaker, Sri Ramchandran. Now we'll break for lunch, and I will request you all to come back as early as possible. So we have many interesting sessions, some demonstration from CA side, some demonstration on Java and Python regarding the digital signature and verification process, as well as the encryption and decryption using public key, private key. So please come back at the earliest. Thank you. Please try to come by 2:15. Thank you.
Hello. Check one. Hello.
Hi, good afternoon all. Good afternoon from eMudra. Yeah, hi all. So welcome back after lunch and good afternoon from eMudra. So I'm just going to present one of the product from eMudra Labs, that's mobile-based digital signature. So till now we have seen like crypto token, like private keys putting in a token or as a PFX file, PTL file and all stuff. So every time in the industry we had a question like everything can be in the phone, then why can't we put the digital signatures in the phone? So like GPS, camera, music players. So now we have stopped using hundreds of devices, right? It's only one device we have, and that's what we are using for every purpose. So it was always questioned in our industry, like why not to use your mobile? That's where we started this innovative product. So here, what is used is, so PKI technology anyways requires a custodial keys for the signer in order to ensure that's a non-reputation. So even in industry, what happens is even you feel that your token is used by the same person, but it can like people put the token with the password putting, and whenever it has to be used, it's used by someone else who, so that's what. So this non-reputation thing was actually not guaranteed. Current process requires even external USB tokens. Like you are carrying phone with that, like even you have to carry the crypto token. So that was a need currently, and even now crypto tokens, most of them used in India are from made in our neighboring countries. So that was also a security challenge. So logistic challenges. Then after that, like relying on the hardware and all that stuff. So that's what hundreds of challenges were there in the crypto tokens. So that's what was there. So all the above challenges can be addressed with the advent of the mobile PKI for Indian DSCs. So that's what we are going to present. So what we researched and found is like in Apple anyways, they Apple iPhone 11, they use there's a FIPS 140F2 level certified. Even Galaxy phones, S series, J series and all, they're having, they use the strong box concept. Google Pixels are strong box, they use a strong box concept. Top of that, even Google uses the secure key attestation concept and all this stuff. And even if you see the lower end phones, there is a hardware backed key store and all, like TE concept and all is used. So that's what in this demo, we are going to use this concept for storing your private key and using that for signing. So I'll not kill more time in the taking on a technical part. Let me just directly jump to the some certain demonstration so that it goes more interesting. So there are 4 different ways of utilizing the signing actually. So first concept is you can either use a API to sign a document. So you can just generate a hash, pass it to mobile through some API, through some server, and then you can sign the hash, get a signature back, and then pad in a document so to get digitally signed. Second concept is we also give a Microsoft CSP or PKC11 DLLs that you can use in your application for signing. Third concept goes is in Acrobat Reader, we have enabled like as Microsoft CSP is there. So in Acrobat Reader that I'm going to demonstrate where you can sign in Acrobat Reader where the private key is there in the phone. So that's what you can do it. And fourth, our one of the product is very popular. They called EMBridge that's used throughout. So that EMBridge also you can use like that is used in income tax and all several portals. So you can just if you EMBridge you're already using, so it will show one more option as mobile PKI and you can just use that option for signing. So anywhere in the existing industry, it's not going to impact like MCA or Ministry or whatever the income tax or where your portal you've already integrated, it's not going to impact anywhere. So let me demonstrate one of this. So you can just watch this video and in between I'll explain that. So this is not a final thing. It's just a demonstration application. So first what happens is you need to apply a certificate from a certifying authority. You get a application ID or challenge code so that you can put in your mobile. And that's what this user is doing, entering his application ID with a challenge code. So now CA will get a request to like first the private key pair is generated, CSI generated, the CSI went to the certifying authority. So he has got a DN details that he is verifying. And even in the green, it shows that, how secure is your mobile? You should download the certificate in that or not. Then he's clicking on download and certificate is downloaded successfully in his phone. So next is going to use it for signing purpose. So here you can see the request and all. So this is a C application where you can see the request, what all requests are there for pending or completed. And even like in this demo, these demonstrations, we have tried to show one-to-one, like self-using. But you can even send it to your CFO, CEO, or CTO, whoever has to sign the document. So the signing authority, you can send the document to get it digitally signed. So here through a web application, we have tried to sign the document. So you can place a signature position. And in here, what happens is instead of token password, it's a every time a unique PIN gets generated. So that PIN is generated in your mobile application, and that same you can enter in your respective signing application. And that's all. Click proceed. You get a request in your phone, or maybe who the signing authority is there. He'll get a request on his phone, and that's what he just need to select the certificate, and signing is done. So this is the one of the use case. Let me take you through other use cases. So this I told you, right? So we have a popular application, signing application. So that's EMBridge. Let's do that. So here what happens is in most of the portals you have seen, like maybe income tax you have used. So they give a provider like the token selection. So token, instead of selecting another token, you can select the mobile PKI. Certificate will list here. So you can select the certificate in the phone, that's what you can select it. And then enter the PIN from the phone again. And that way you can sign. So that's simple. The document is digitally signed. He just selected the certificate, what he wants to use, and so you can see the document is already digitally signed. Let me show the last most important use case. That is, you can see in the phone, in your in user system, there is no certificate there. So first what happens is he pairs his system with the phone. So you can say Windows Store is pairing with his phone. He puts the authentication code. And in his mobile, he accepts the request to pair with his system. So root certificates also get installed during this process. Finally, you can see in his system, he gets the certificate. And now he can use it for signing in any application. So it's more on, you can say, Microsoft CSP based. So here's this opening in the Acrobat Reader. And he's signing one MCT form. So here's a certificate. And in his private case in the phone, so he will get a request on the mobile and then yeah, he has to sign it. So that's it. So yeah, I'm almost done on this part. Anyone having any question? I didn't discuss more on the security part and all this stuff. If still you have any questions, you can ask. I just wanted to demonstrate the use case. So. Yeah.
And then during the signing, how is
See, what happens is there's a push notification concept, right? So what we do is whenever you are signing in any application, so from that application, the request will go to the server. From server, you will get the push notification to the phone. Like suppose you're signing authority has to sign or you have to sign the document. So you will get a push notification on the mobile. Once you click on the push notification or you go to your pending request and all, you can find that these requests are pending. You can select that. Then it will ask you to select the which certificate you want to use, like which private key you want to use to sign that. You select that. Signing is done. The signed packet, either PKCS1 actually we are using currently. So PKCS1 goes to the server, PKCS7 get formed. Then that PKCS7 goes to the respective signing application. It pads or adds in a document. It gets digitally signed. So that way. Is it clear or you want me to more elaborate it? The private key was there in the mobile. Yeah, so mobiles are now FIPS 140 of 2 certified. So iPhone and Samsung phones, then Google Pixel. So they are FIPS certified actually. Yeah.
he has shown one diagram.
But when a development application or it should be a complete module. It should be complete module certified.
Yeah, that complete FIPS certified models are TE or Strongbox or Secure Enclave.
Along with the software, hardware, everything makes up FIPS module, FIPS certified.
Yeah, so that's what. So
in your case, it was a chip only the FIPS certified, and the application is not a FIPS certified, right?
So no, signing up. You want me to say signing application or which application is not certified? Signing applications are never FIPS certified. It's only the storage part. Yeah.
That should be in a
FIPS.
And what is the condition of yours not allowing the private key outside? It's a firmware or something you would have been using for it, wherein the private key will never come out of the mobile.
Yeah. So
right?
Yeah.
In that case, my phone along with that firmware to be certified as a FIPS certified.
So yeah. So now these all.
Yeah. Electronics needs to be. And also you are doing the application on the mobile in application where that application is also not certified.
So that application is more for it's a signing application. That's what. So even if you see now the PKCS level libraries and all, they are not FIPS certified, right? FIPS certified is where the private key is getting stored. So that layer is FIPS certified. So even if you see iPhone, so that part is FIPS certified. iPhone 11 and also that way it is.
complaint is there.
Yeah.
Complaint not only on the chip, it has to be on the overall integration of the work has to be done.
It
Because
is,
we are talking about the token point of view.
the same thing is there also, yeah. Yeah,
Mobile, yeah, there's a token there.
that's
what
right,
we
sir,
are
that's
talking
right,
about.
that's right, yeah.
So in that case, that token.
Our
so
mob-
the one
our-
getting,
Yes, sir.
It's compliant.
Right.
Here only the already existing crypto module, the crypto module which is within the chip, which is certified by the OEM, whether Apple or Samsung, which is getting a certificate from the chip manufacturer.
Right, sir.
So whether the application overall built on the chip, so whether that is certified.
No, like now also if you see the PKS11 part is not FIPS certified, right? PKS11 part is separate only, it's not part of, yeah, that way, yeah.
Question also, in that case,
Yeah.
in that case, the token has to be on a FIPS compliant chip only, not the overall built up product should be a FIPS compliant. That's what the
That's right,
discussion has been.
yeah.
So in what way you are going to compensate for that, whether you are going for security audit or what are the other channels to ensure that overall build-up application on the mobile.
Yeah, so
phone-
that also like from last 3-4 months, thanks to CDAC, yeah, we are already there in under testing, so that way.
So one my point is,
It's a simple application wherein taking a mobile from an iPhone 15 or something, and I can develop the application and I can make it. But what are the main concern of the CTI is the FIPS certified thing. Rather than
You will do cross check on the existing the tokens, whether the token itself is compliant or only the chip which is dumped on the device.
The only chip is compliant, sir.
Only the chip. It is not the.
Not the
overall
application, yeah.
complete boundary, they go for the middleware, the
The
software,
firmware.
hardware, enable firmware, complete solution is go for the.
No, so it's either FIPS compliant.
Otherwise it will-
So
No,
here.
otherwise it will be like a memory storage which is FIPS compliant, not a module.
where cryptographic library resides, either on phone or.
It's inside the TE part. So cryptographic things are already trusted execution environment.
We have not seen exactly how EPS were generated on the mobile itself.
Yeah.
Because after generating certificates and everything is on the mobile, we are just using by invoking server to the mobile to sign the document or packet. Whatever.
Yeah, so what?
First request will go to the server and server giving alert to the mobile, and then accordingly mobile will sign.
That's
So
right,
this
sir.
all cryptographic library reside within the mobile or not?
Yeah, those all reside in the mobile only. So there's a trusted execution environment, so TE part. So it all goes inside a TE. And same concept is used to store your face ID or fingerprint or PIN and everything. So
Reside in
that
the TE.
TE only, yes, sir. So everything goes inside the TE. So there's a separate processor, there's separate, you can
And
say
that- in that
storage,
case,
everything.
That portion is already.
It's an isolated thing, and that part is actually certified. That complete is not SIPS compliant, that chip is SIPS compliant, yes, sir.
How is the key being used here? How is the key being used here? The key, the private key, how is it being used here? Who is actually invoking the key? Whether it is PKCS11 directly, is there a software implementation of PKC of cryptographic
So actually,
operations?
in both the cases, Apple and Android, they expose certain methods, and that methods can be used. So in that using that method, only that application using that user, you can access those private keys for whatever purpose you want to use.
But this key is not generated by Apple.
Wherein I can use that private key also.
No, no.
What I can make another application wherein I can. use
No,
the
that you
private
can't
key.
use that private key. That private key is restricted for the. No, that private key. That private key can be only used by the same application by the same user. No other can use it. And it is one thing to add it here is thanks to CTEC Hyderabad, we are already in a rigorous testing from last 3-4 months. So rooted devices, without rooted devices and all, and we have almost not found any major issue in that. So that's what we are under rigorous testing on this part.
No, testing is one part.
Yes, sir.
Testing is something different from the FIPS.
Yeah.
Whether we go back to the crypto module of FIPS compliant, FIPS compliant based on the crypto module, the chip where the hardware chip public and private is going to store.
Yes.
Their point is that whatever the building apart from that overall, the TE module, which is completely different from the FIPS chip.
Yes, sir.
Because the crypto module, it is a parallel operation, you go to fetch the public and private key.
Right, sir.
Their point is that because they are also working the same angle.
Yeah.
So their point is that if I go with that, how do I ensure that my whole system is compliant? It, frankly speaking, it's not. You said Switch complaint, it is a chip which is already Switch complaint by the chip,
Right,
not
sir.
the overall operation built on the chip.
That's right, sir.
Correct? Yes.
That's right.
Because that is, you cannot ensure that, you can ensure.
But they have NIST license, and also from NIST they have got certification on that part. So those all can be evaluated. Even if you want separately, we can sit and evaluate that. That's not an issue.
Certified from where?
NIST. So we can separately discuss on that. So that's not an issue. So open point we can discuss anytime. Yeah. Anyone having any other question?
Yeah, I'll just add one thing. Have you seen Jorki?
Yeah.
So I thought that these questions will not come if you use Jorki. I'm not endorsing. I'm just saying that you can use your existing crypto token, just one USB-C converter. Anyway, nowadays we are using with all MacBook. So connect that Jorki with your mobile phone, and whatever operation is doing, same operations. Yes.
No, there the certain challenge was again like transferring the data to Jorki server and all this stuff. These all were the challenge earlier. So like maybe the data going or the certificate download happening through some third-party application. So anyways, that is separate discussion.
Token, nothing goes out of it.
Yeah, no, that's a separate discussion that we can.
Jorki is the external device. where
That's
you
what, yeah.
connect it, But here on
Yes.
the SIM itself, it is keys are where generated.
No, but in Jorki, you are using the crypto token itself, which is.
Yeah, but again, you need to carry two devices, right? Like
Jorki use mobile for only authentication purpose. They have not used mobile as a cryptography token. They actually use the cryptography token.
Yeah. Original cryptographic.
And the last question, is it verified from CCA side?
so we are working on that, and thanks to CCA, like they are only supporting us, always guiding our Banati sir and all, like roaming Hyderabad, Bangalore. So aggressively, yeah, CCA, we are thankful to CCA for supporting on this point.
But question is that whole mobile is not act as a cryptography token. It's a cryptography token is a safer side. Like same motherboard is accessed by other devices, other chipset is also integrated in the same motherboard.
We always welcome your all expertise. So we are ready to like modify, change, or whatever is there. So that we can work together on this. That's not an issue.
Thank you.
That way. Yeah.
Make it open, maybe we will also test.
Yeah, sure, sir, sure.
And here, one more question, wherein in the web page, you do some upload a document where, which is the document you need to sign and everything.
Right.
When you put the hash data to the mobile, right?
Mhm.
And after that, you get the sign and everything, is it all been in a plain secure manner or how?
So again, the signing application. So it's again in the signing application. So whatever the mobile application is seeing, that's a CA application. Whatever components we are giving, those all are the components. So even we are testing everything. So what happens is, yeah, secure in the sense the hash coming, it can come in the secure channel. You can, if you want to pass, you can just add maybe session encryption or maybe you add additional encryption there. You can add it. So there's no, it's more on the part of the app. So what is the signing application features? It's not about the key storage and all the stuff. So that way. You can build as many you want to add their security layers.
Then how many certificates can decide on your SIM?
It is again on the phone storage, sir. Like we have not found any difficulty. Like we haven't downloaded 1,000 certificate and all. It was we were able to download.
Two certificates are deciding, then your server receive the request for sign. It will some issue will happen or not?
No, those all we have tested. So even if you're having 5 certificates in the phone and you are using Acrobat Reader concept also, that also you can use it. So we have already tested those parts. So that never gets in problems.
What is the application they get for?
Really, see, the basis of acceptance of acceptance based on the structured rule, what the CA has to issue certificate, that's it. That is the role of the CCA. Where how they are going to implement have to be complied with the guidelines. That's it.
But I think
So-
it's not satisfied, no?
Which one?
With mobile system and.
No, they're not, it's a new technology they have come out, they are just presenting here for your feedback and input, so you can give your suggestions, right?
Okay, so it will be in future.
In future, we have to take a regular call as well as we have to guide what changes. That depends on the, again, No, it's only that they are doing a demonstration of the new technology.
See, basically CCI and CA, we are more bound towards the certificate download and all this stuff. We are not bound for the signing. So
They have to bound to do that, all the guidelines, compliance, everything. Apart from that, one is they have to follow the compliance as per the PIPs. Secondly, the application built on the PIPs, which one they have to comply. So those things, again, for that, they are taking help of CEDAC Hyderabad for the checking other, hardening the application side. So that we have to check it out, what thing has to be built on over the PIPs compliance. You cannot expect everything PIPs compliance. That's nearly impossible. If it is a PIPs compliance, it's chip in the sense, it has a separate module where the public and private goes and stores there. It becomes zeroized once you try to break it. So these are the added features what PIPs makes, and it is compliant for the particular chip from the fabrication level. Once it is PIPs compliant, as per the compliance, then it can be utilized by any user, they can start building up. Still, if you want to say no, suppose for example the token, still you want to go for a PIPs compliant the whole token device. What again you have to rigorously go with the PIPs. You have to ensure that this is the firmware which will be dumped off the token. It means that over above you cannot do anything. Any change, any minor change, again it has to go back to PIPs for the compliance. Again, audit compliance, everything it has to come to the channel. Coming back, suppose for example he has taken only the PIPs chip. He is building his own application. Then it has to go for a hardening of the application side.
But someone will certify, and this application, what they have made is
Oh, exactly.
no, if it is required, we can go for EAL certification and all that. Later we can come. That's not an issue. Yeah.
They are planning, they have to go ahead or testing, they have to check all the vulnerability gaps. So what are the things have to be blocked, how the firmware has to react to the firmware. So see, now it becomes a harder software, the combination of acknowledgement between the how, see, the main goal is the how the key has to be stored in the PIPs. Whether it is having a provision to come out or not. Whether it will come blindly, it's not going to come. It's going to store within the crypto module. Top of it, when you build a firmware, are you giving a provision to bring it out? Those hardening tests will be done at the other testing factors. If you say, again, I'll go with PIPs, which is okay, it is hardened, no more change should be applicable. This is the final firmware. If it is not matching, then some change has been done.
it will be additional kind of
It's additional. You have to come out stating that I have hardened my system, no more further upgradation, any further upgradation, again, you will go for the regular procedure to check the audit compliance. Yes, exactly right. You are planning.
That's right. Sir, that's right.
If the chip has a PIPs compliance change, one thing is.
No, that fifth certification not from our side. That's more from Apple, Samsung, Google. So that's great. No, so application is signing application or certificate download application. So even if you see now also, so in token everything is not FIPS certified, right? Literally, if you see. So whatever is the FIPS boundary, that if any change is happening, that has to get certified. That's Apple's responsibility. We are not going for FIPS certification.
No, you got it? Yeah, let us see, whatever within the boundary of its compliant, okay, I'll say ABC, this is compliant, I will publish the certificate. Apart from the A for one, he has to again go back. If not, he will go to the building application over it. Again, he has to go for another channel of application to strengthen this hardening of the device, right? So
That's
what
right.
we're planning to do with your application as well.
That's right, sir. So we are not going for any FIPS certification. FIPS is from Apple, Samsung, Google. So they, yeah, right.
Only chip is come.
But in case of a dongle, it's the core or it's a picture phone?
This chip only. It's not complete. Like even PKS11 part and all this stuff, they're not FIPS certified. Only that part, that boundary is limited to that only. Maybe someone from token manufacturer, they can explain it.
Chip is compliant.
Not everything FIPS. Not everything is not FIPS certified. You can't have actually.
If it is hardened, then it is restricted only for the token.
And everything complete hardware version, everything they do. These are the version in which my certification side channel attack and everything get over and everything, and everything below, and then give the certificate. When there is a change in that particular hardware, my chips get invalid. That's what I was saying, that in that case, in the mobile phone also,
If you can cross-check, I'm not, my opinion, if you can cross-check, the firmware, approved the chips for the particular model, because every model changes. Composite, the firmware changes, again, the chip complaint is gone. Yes, that's what I'm saying, it's gone. Again, you have to go back, because normally people don't do that. Because we understand that, based on the chip number, okay, it is done. We cross-check the firmware, 100% sure the firmware.
Because it's
from
again the user
point
and
of,
right? So
complaint chip.
we have to visualize that.
Because they keep upgrading it, they won't go
We're
back,
not
again,
showing
go back, going
that
back to the
story, no? It goes application keys used actually to store that, encrypt that and store it. So if you delete it, it's not known user, you can't use it. And even other user logins in that, you can't use it. So with your authentication, your phone will test to it. That's similar what can be used by multiple. The login will be different. Again. So both will have different.
You can be able to see what are the kids there.
It is not like cross, like even in
From that point,
Windows
whether
instance,
we-
you have
the
multiple
models
user
they
login,
agree
or
with
Mac
that
have multiple
for
user
normally
login.
what they
So
do is
that
they
user
take
the
it-
thinks as user that
they
user,
build the
other user have their own.
Again, they go for that certification. The overall body get compliant. Then it means no more changes executed.
But in that also partition that I am not. No, so here what happens is this particular the keys are generated. That's the application specific, user specific. So other applications can the banking also. What is the pin also? Yes, sir. Yeah, please.
I have a question. I have a question. See, I have, as per my understanding, we have read security policies document for the SPIPS related certifications
Okay.
of the donors.
Yeah.
In that, we have not seen that only chip, they are talking only chip.
Okay.
So somewhere in some dongle, they are giving a product as a complete boundary of a SPIPS certification.
Okay.
So it is a black box.
Okay.
Sometimes it is a black box with a photograph of the dongle. And it is saying that this is my cryptographic boundary.
No, maybe we can separately connect on this, and that way we can check on whatever part you're talking. But I can ensure you similar guarantee you get in the this new phones, whatever we are talking about, like Samsung, Apple, and
Phone. It's a hardware critical dongle. And
Yeah.
in terms of this.
This whole
No,
module,
complete-
including the chip and the firmware on it, and including the application or whatever the details that the producer has
Get
done.
this photograph of this as a complete boundary.
Okay, separately maybe we can discuss on this, so that way we can check. this.
In dongle, it is a single component of
Yeah.
dongle, that's why everything of chips
Yes.
required. But here on SIM, there are multiple things.
Because
are-
now a simple
One
thing is
the
there.
fixed boundary, where key pairs resides, private key. Rest of the things are phone part, where phone's memory or rest of the things reside. First one, he has to decide, or manufacturer OEM will decide if which application does not hamper its fixed boundary. Yeah, actually, those certifications are, if it's give, and it ensures that nothing will happen, and in the future updates on the cryptographic standards which are providing on the mobile SIM, then it's okay. But anyway, the agency will give the certificate, na?
But we can't assure for all
See,
those
cryptographic
applications.
boundary.
Now he is under development.
There are two
Because
things actually.
If you block everything, then nothing will go up. So at least he is trying to do things. Maybe after a year or 2 years, the things will be resolved and some new standards will come.
Yeah, of course, sir.
Yeah, there are two things actually. Now only there was a change, right? Adding a prefix in the serial number generation change and all this stuff. Had any vendor went for a new FIPS certification? No, right? Second thing is generally what happens is most of what is my understanding is, or maybe whatever I've read by that is this the mostly the FIPS, whatever the chip they get, right? That's what is FIPS certified. On top of that, it's more on it's our local vendors, they put whatever they have to put on top of that. Those all part are not never FIPS certified. So even if you want separately, we can discuss that. Yeah.
Personalization thing.
Yeah.
That can be personalized as per the new guidelines or old guidelines. Yeah, that is a separate thing. But the product, the fresh product which is not personalized, what we have seen it from the certificate of the FIPS.
Yeah, it's again on that like token manufacturer only. Whatever they want to FIPS certify, they can get that FIPS certification. Yeah.
There is no such guideline. What is the cryptographic boundary should be for cryptographic tokens.
That's right, true actually.
Because one OEM is claiming only chip as a cryptographic boundary. One can see a photograph of this cryptographic token and this is my mobile. So this
So
is
if we talk about the architectural level, we see because it has multiple modules in there. So apart from that particular chip, there is one small module, the crypto module. Within the crypto module only, whole packet of storing the public and private key happens. It cannot flow out of that. That is for sure. So in that case, we cannot claim that only the crypto module is my boundary. The overall chip architecture is the boundary.
So, sir, in that case, long back we have discussed with Emudra also. In that, what is the guidelines and how they are issuing the certificate to the device? That was the discussion was going on. In that, it is ensured that we, as Emudra, issue a certificate to a FIPS compliant device only, as
That's right.
listed by the CC.
That's right.
Right. So it is FIPS compliant device, which is the only module, or it is the device.
So it's more on there is an audit happens, they give us an audit report, we accept that. So that's why we can take it separately. That's right. Yeah.
Thank you.
Yeah, thanks everyone. Thank you for your patience.
Yeah, please. So our next presentation is from Precision.
Okay, earlier we are using cryptographic device isolated way, like dongle, HSM device, etc. But nowadays we are combining with the module like in application itself or in system or even in mobile. So all should come together so that there is a hassle-free environment because we have to no need to connect any device with the mobile or system, etc. And within the cryptographic library or boundary, we can use proper way like FIPS allows. But we are trying to do that. But definitely the security issue is there. Definitely we should clear the security issues from all angles from the experts' point of view. Then okay, we will able to use in future also.
Thank you, sir. So good afternoon. My name is Ravi. Good afternoon. My name is Ravi. I'm from Precision. And I see that there's a lot more energy. Normally after lunch, it tends to be a sleepy session. But today, I think lunch has given us a lot of incentive to talk about nice things. And unfortunately, I come at a stage where I think all of you have the questions for me because you are asking the questions to Mr. Raj. But I think I'm going to get caught in the same thing. I'll try to do my best, but there are lots of ifs and buts, so we'll go through that. So I'll not bore you with too much of Precision, just basically 25-year-old company, about 2,000, 3,000 employees all over India. And why am I here? I'm here because of the need to develop an indigenous hardware for crypto tokens. So all the crypto tokens that we are using today comes from border sharing countries. You know what that means. We are a company who's developing a token, hardware token, everything inbuilt with no border sharing components. Now, just a minute. Yeah, good. Now, before I go into the hardware itself, I think most of you may be aware of this, but just to give a context to the whole thing, let me talk about, I think today in the morning, Mr. Ramakrishnan talked about the act. There is an act and there are guidelines. Now, the guideline is not just everything should be FIPS 140-2 compliant, but the guideline goes into a lot of details. So what you see on the right-hand side are about 17 different aspects of a token, a security token to be certified. These are the CCA guidelines which govern how a token is certified. So a lot of questions that you had asked, how do I certify a phone, will also apply to this category. Now, they said the guidelines are available there. The security requirements. So basically, how does one define a guideline? There's a list of requirements that CCA has been kind enough to document. It's all documented in the CCA procedures. And the central theme of that is FIPS 140-2. 140-2 is not adequate. If I put a module called 140-2, it doesn't automatically make that Indian government CCA approved token. We have to do a lot more things other than that. And this guideline, if you go into details of each one of this, some of these points will say, this is equivalent to FIPS 140-2 and hence complying to FIPS 140-2 is adequate. In some other cases, say, let's say key output. For key output, they would say that if it is FIPS 140-2 certified, it's not enough. You have to show evidence that you have configured the chip in such a way that your private key is not exported. It's not just enough to say, I have a module which is FIPS 140-2, I'm certified. No, you have to go to the auditors and demonstrate and prove to them that it is not, you have configured the system in such a way that private key cannot be exported. So in each one of these clauses, in some clauses it says, if you comply to 140-2, you're okay. There's nothing more needs to be done. In certain clauses, there are additional testings that CCA has stipulated that we should go through to be certified. Now, what I think I'll request a transparent set of tokens. What's the whole block? Pass the whole thing as it is. Okay. So far you've been hearing mostly software part. So just to give you a touch and feel of what is happening, I've sent around a set of keys. Not just the token that you have seen, but the token broken into pieces and individual components in that, and just for you to get a feel for what it is all about. Now, what we are in the business of doing is we are building this token, which has at its heart FIPS 140-2 compliant thing. And naturally, according to the CCA guidelines, we will we'll have to document how we are implementing all the requirements of the CCA. There'll be an independent certain empaneled auditor who will walk through all these requirements and then certify the token. So obviously no components from border sharing countries. The FIPS 140-2, the TPM module, many of you may have heard of TPM. TPM has been around for many, many years. It's at the heart of security in most of your laptops and computers everywhere. Now what we have done is we have successfully moved that TPM module, which is FIPS certified. When you're talking about certification, is it only the hardware, software? You read everything. Basically, that module contains a firmware. The hardware piece contains firmware. The firmware plus the hardware chip is what is FIPS certified. So everything around the chip is never FIPS certified. Let us say you use a PKCS11 module. The PKCS11 module is just an interface to say how you talk to the token. It is not FIPS certified. The PKCS11 is a standard which says, if you want to create a private key, this is the way you have to do it. It is not FIPS certified. It is the boundary is the chip. The firmware within the chip and the libraries that they have used within the chip to generate the token and to generate the private public key pair and the facilities that they are given by which the private key can never be exported is what makes it FIPS compliant. So so the FIPS module, the TPM module does not have a USB interface. Since the token requires a USB interface, what we have done is we have added a secure controller. Secure controller is SLE78 from Infineon, and it's EAL6 plus certified. I think whole of India, there are certifications EAL4 plus or 4-ish. And this particular chip is EAL6 plus certified, which acts as and this doesn't do any of our digital signature tokens at all. It only acts as a bridge between the USB, between the host and the FIPS certified controller. Okay, it incidentally also implements the FIDO2 compatibility, which is you have a single token in which you can do both signature, signing, authorizations, as well as authentication using FIPS. We have two models. So this is a broad overview of what the two modules are. You may have seen the small hardware being passed around. One is a USB token, which is a USB type A token, which is the one on the left, which I call module 1. And in that you have a TPM module, which is FIPS 140-2 certified, and SLE78, which is a secure controller, which simply acts as a interface to your host. And the TPM module runs on SPI, Serial Peripheral Interface, for those of you who may have forgotten the college days. And there is a chip select which goes from there. In FIPS standards, you also have, in FIDO, you also need a touch to verify a user being present. It kind of avoids malware, authorizing things without some human being physically present. So there is a touch module which is present on the token. In the morning, we heard about digital signature is fundamental to the whole thing. It establishes identity, it ensures security. Absolutely correct. The CCA have been very helpful to us in guiding us, helping us in how we do things. Now, one of the things that is still lacking in the entire infrastructure of digital signature certificate is identity. Now, you have a token. The token is extremely secure. The digital signature is there, but he steals my token. What can I do? He has watched by typing my password, so he knows the key. So which means I am liable to everything that he might do. I'm not pointing to him, but I did. Okay, so now what we have done is, we are in the second model, we have combined the biometric with the TPM, which is FIPS compliant and FIPS 140-2 compliant module along with the biometric. Now, the moment I say biometric, a lot of people say, oh, that's taking away my private information and putting it in the cloud and dangerous. In this case, what we have selected is what is called as a SOC, a system on chip. This system on chip encrypts your fingerprint and stores it internally. Even via the interface, I cannot get any information about your fingerprint. It allows me to enroll the fingerprint and only authenticate whether the user's fingerprint matched with that and gives me a true or false. It also tells me which is the fingerprint. You can enroll about, like you do in your mobile, you enroll n number of fingerprints, 5, 10, and then it will tell me that it is authenticated, based on which I go and sign a document. So when you want to sign a document, all that I will do is I will first authenticate the user before I go and sign. So it means if I allocate this to a minister, the minister cannot claim that and only his fingerprints are enrolled in this. It cannot be given to a secretary for signing. He has to put his fingerprint on this, which means there is absolute non-repudiation to ensure that he is held liable because he has put his fingerprint when doing the signature. So that is the level of complexity we are going into. I must warn you that these are all not certified. We are still in discussions. There are hundreds of questions that come to me. I try to answer them. We work with the CCA to bridge all the gaps that they find in our tokens, and we try to bridge it. We try to get it to an approved state as soon as possible so that there'll be a homemade Atmanirbhar hardware token available. Now,
Can I ask one question?
please go.
Go back to your previous slide. So in this case, both are the secure controllers. DPM is also a secure hardware.
Sorry.
DPM is also a secure hardware. Secure controller is also a secure system. So where we are generating this key and storing this key?
I
Because
this,
who has the crypto accelerator?
yeah, absolutely. I was fighting with the CCA for almost a year. I didn't succeed. So I went in for the second one. It is both, they are both secure, but from a regulatory perspective, only the TPM is FIPS 140-2 certified, and hence all crypto operations happen only in the FIPS certified TPM module. The secure controller, which also has a lot of other things, which if you ask me, that's also secure, but it is not compliant to the standards as laid down. And that's the reason why we have gone in for a separate TPM certified module. And that module, along with the particular version of the firmware, Mr. Pandian was pointing out that it's not just the hardware which is important, the firmware as well, which is the firmware 16 of that module is what is FIPS certified, and we'll be using that. And we will not do any changes to the firmware on the TPM module. The TPM module remains 100% same. We just send commands to it and get it back. So that is 100% certified, and we just send commands. The command will be sent from the secure controller. And what we try to do is we try to establish security around the whole thing by ensuring that there is a secure channel established between your server or driver or whatever you're using till that particular chip. Because of the fact that it is a secure controller, it is EAL6+ certified controller, we have good assurance of secure communication till that end. Like go to WhatsApp, it says end-to-end encrypted. So even though it goes through the internet and goes through multiple switches and whatnot, it is still encrypted between the token and the partner. The partner may be the PKCS11 driver, the partner may be a server, doesn't matter. It is encrypted between the partner and the secure controller, and the communication between the secure controller SLE78 and TPM itself is secured, and TPM is certified to FIPS 140-2. That's how.
In this case, what will be the boundary of 50?
It's just the TPM. It's only the TPM.
Then it is not need for certification of the device.
We will not go in for certification of the entire token once again. We will go in for CCA regulatory approval in order to use this FIPS certified. All the correct. So CCA have put guidelines and said this, if you do FIPS 140-2 module, you're okay. These things, no, you're not okay. You should do A, B, C, D. And the empaneled auditor will test that in our device to verify that we do all those things that CCA's guideline says we want. And if we do all that, they will certify it, and then it will go to the CCA for their concurrence. Inside the TPM, yes, absolutely. Nothing comes out other than the public key. Nothing else comes out of the TPM module. The TPM.
Using both secure controller, and so price of it will go high. So
yeah, we'll all pay a little bit more. My company, I'll become richer. No, I'm just joking. Basically, the TPM module does not have a USB interface. So we have to put a USB interface. The USB to SPA controller, just the bridge, if you put a USB to SPA bridge, it will cost almost as much as the secure controller. Naturally, we have to develop a lot of firmware, but everything is in our control. It's a EAL6+ certified controller. So we took the option of ensuring that the security is paramount, and we have, instead of going in for a FTDI USB to SPA chip, we have gone in for SLE. Okay.
My question is why you are using biometrics in a separate USB, Type-C or A? Why not you are using biometrics as a key component of the, like a public key in the certificates itself?
So,
because certificate has multiple variants. You can see the certificate as the subject identifier, completely privacy, etc. One of the key field you may choose as a biometrics content, and where you can put hash of the biometrics in the certificates. As soon as when you compare your biometrics fingerprint through device or your token, that hash will recalculate from the stored hash in the certificate itself.
If you're I'm not sure that I understand your question, but if you're talking about adding an attribute as to, we can add an attribute saying this particular document was signed using this fingerprint on the biometric, on the certificate.
Missing that you have told earlier that certificate is being used private key usage based on the PIN or password, where your biometrics contents is missing, because anyone can take your token, they can use by knowing your PIN or password.
Yes.
Only thing is, once you are integrating your biometric fingerprint, it will make full proof of the certificate usage, this DSC usage.
Yeah.
So why not we are using fingerprint hash, our fingerprint hash in the certificate as a part?
We will consider that, sir. Thanks for your input. We will consider that.
Eliminate the storing the fingerprint separately on any SIM or any USB, so that at the time of validation or authentication, one PIN is required, another your fingerprint is required to validate through your stored in the digital signatures part.
I understand the proposal and I think it's very valid. We will consider
It is
that.
more easier that because no man can use without their fingerprint digital signature.
So, if I enroll, let's say 4 fingerprints, then I can take the content of the 4 fingerprints, include it in my certificate hash. That is something we can consider, sir. So, what I'll do now is I'll try to do a quick demo of this. I'm never good at demos, and for me, demos never work. Let me see. Oops, sorry. Any connection that I can get to the internet on this? Doesn't seem to connect to me. Internet connection. It's come up. My phone has come up. So let me try that. Good. Actually, it's going to be a little slow because using on my mobile phone. Yeah. So this particular product is called Innate Key, and Innate is something, a brand name that we have. Innate is something that's inherent to you. We just changed IT there to mean sort of IN and ATE, we put IT there. So basically now it's asking me to log into a site with the fingerprint. All that I did was I inserted the device, put my fingerprint, and it has logged me into it. Okay. Now, what did it do? There is a whole lot of PKI involved. I'll not go into the technical aspects because I was mainly focused on presenting the hardware token to you. The intent is not to explain the architecture of mine, but this also uses PKI, and this is our preferred way of applications logging in. We were talking about applications logging in. The application today, just now, logged in with no password from me, just with my fingerprint, which I had enrolled and earlier registered. It knows who I am, and it's taking me there. This is the ideal, in my opinion, a way in which an application can log in with all this. And we also work with banks, et cetera, to do this. Now, all that I want to kind of demonstrate is, if it all works, is a document sign. This is not part of our product. There's something that we have developed. It's test, prototype, still. All that we do is, instead of, we still not develop, we will be developing a PKCS11 driver for this and supplying it to the CEAs, and they will integrate it into their tool set for digital signing and all that. So we are the hardware manufacturers of the token, and we assist in writing the drivers to store the ask the token to create the keypad. Token will create the keypad, and the certificates will be stored there. We can ask it to sign. We write the drivers as well as do the manufacturing of the hardware. This is just a simple demonstration of how we can. So this is a particular sample document that I've taken, and I select the location where I am. I'll still say I'm Chennai, so it's already there. And then if I want to place a signature, you say click on signature, something comes up. And let's say I put my signature here. Once I put that, and I say sign with the TPM module. So all this will change, sign with digital signature. So when I sign with the TPM, it says, give me the credential. I can have more than one credential. I select the credential and type the password and ask it to sign. It's signed. And I download the file. I download the signed file, and that's number 7. So I've been trying hard to ensure that it works today. 6 times I've tried earlier. Let's see whether this one works. Okay, that's me. So basically what it did was it went into the, it took the hash of the PDF, sent it to the token, got the token signed, came here, added it to the PDF, and that's what you see here. Now, if I click on the certificate in this part, it says, show me the signature properties. It tells you all the signatures valid, shows signer certificate. This is the 4 levels that people were talking about. So this is a certificate that has been issued by the test environment of eMudhra. So we are working with CAs in order to do this. So eMudhra testing environment. So that's what has certified this. And for testing, I've used my colleague's name, Jagannathan, whose certificates were put inside this device, and eMudhra, sub-CA, CA, and going to the root CCA. So this is the way in which you can store the sign a document digitally. And we also have a customer can have in his place, get the certificate issued directly using the browser onto his token. So we are trying to generate a Atmanirbhar token so that we all have control over everything that we are doing, and rest of it, we're working closely with the CCA to get necessary acceptance. Any questions?
Yeah.
Thank you.
When you are signing this PDF, you have clicked the sign with TPM.
Signed with TPM. Yeah.
There are another link was there, signed PDF. There is the difference between these two.
No, basically we have, I mean, I should have hit that. It was not meant for this. The secure controller also has a facility to sign. So we have 2 products, actually one with the TPM, one without the TPM. If you don't want digital signature, which is legally binding, I can sign with the secure controller. If you want a one which is legally binding, I have to get the token certified by CCA, certificate issued by a CA, then you can get a digitally valid, I mean, valid in a court of law is what is the digitally signed TPM. The other one is not valid in the court of law, but if you are willing to take the technical aspects of it, I can sign.
In that case, both controllers are having the sign.
They have the signing capabilities. One is EAL 6+ certified, one is FIPS 140-2 certified. If you do a strict comparison, the older versions of the FIPS 140-2 said EAL 2+ or 3 is equivalent to FIPS 140-2. Now, latest things don't say anything about it. So this is EAL 6+ certified. So this should be better, but it is not complying to the Indian standards. So that's the reason why we use the.
Are you using any WebSocket-based PKI component for signing?
This particular thing is a simple demo. So here we do use, we don't use WebSocket, we use a server-side event, SSE, to communicate, to have events set across in an encrypted channel.
No. But in the practical case, token.
Practical case, we will provide a PKCS11 driver to the user and they can use it. Now, we are also attempting to see whether over a period of time, the signatures can happen using a browser. So these tokens, we have also not just copied whatever was there Chinese, we have done it in such a manner that it is possible to communicate via a USB HID supporting browser, which is Chrome and Edge, both support. So 2 or 3 browsers support USB HID, and you will be able to communicate without installing a driver. So in my laptop, there's no driver installed and I can sign everything, but that is a matter which is subject to more audits and more questions, more answers, but we will get there.
So it's types of browser extension, or you will use
No, it is built into the browser. It's built into the browser. The browser, you know, something called WebAuthn. So that allows you to communicate the OS allows you to communicate with the token seamlessly, securely for FIDO and WebAuthn. The same method is what we are using to piggyback and send messages to the token. So basically, when you have a driver, what does the driver do? Your browser talks to the driver, driver talks to the device. The driver is the only mechanism which was available earlier to talk to the token. Now we can talk from the browser. Whether it is acceptable to the CCA, CEAs, that's all subject to discussions. Nothing is.
Has to be compliant as a CCID compliant. So in that case,
it is HID compliant.
CCID, USB CCID compliant. In that case, you require a driver, local WebSocket, or browser extension. In case of HID, which FIDO talks about, in that case, HID, because browser support HID interface.
So this particular device supports HID.
Current token in the market is all CCID compliant. It needs to be checked at what CCA guidelines says.
Yeah. So today there is no requirement. It just so happens that all the border sharing countries chips decide to use that particular model. We have gone the other way so that it allows you to do a browser to device communication on all different OSs. You don't have to have any driver at all. You can go to Linux, Mac, Android, iOS, talk to the device. So to allow that, we have gone in that. There is no specification saying it should be this type of HID or no. So we have a CTAP2.
It needs to be some.
It is just like we have not installed Acrobat, reader, and still browser is opening our PDF file. In the same manner, your driver is working through browser.
So
it is
always
installed at client.
Yeah. So today the driver is installed in the client. If you install the driver in the client, it will continue to work exactly the way it has been doing so far, and that is what we will definitely support.
Yeah.
We are just pointing out that it is also possible in the future if things change and CCA are willing to approve, there is a demand and it's deemed as secure, that you can send a message from the server via the browser and talk to the device. Because the security of the FIPS part is in the TPM module, which is also sitting behind the secure controller. The PKCS11 module, which is the driver, itself is not FIPS certified. It's only a mechanism by which the commands are sent to the token. So the browser can also send, provided there is secure communication established between the token and the source, which may be the server or the host itself. So these are subject to technical clarifications and people getting convinced that it will work and it's secure. We are in the process of doing that. But today we will give a PKCS11 driver so everybody is happy. And then if the next step of innovation comes in and people permit us to do that, we will establish that the communication between the server and the token is 100% secure. That's a secure controller, EAL6+ certified, doing all these things for you, generating a random number, challenging, doing PKI between the server and this, all that we have done. It's just a matter of explaining this to people, getting their confidence, having it tested, certified by an independent lab. These are pending.
But for your token, once you plug in token in the system, it will automatically get installed, or it will ask the driver to install.
That today we don't,
But
it can, the CA will work with it to automatically install the driver. So we give the PKCS11 driver to the CAs. CAs bundle it along with their product. Whatever the current mechanism that they adopt, I would expect them to adopt the same thing. Today is the first day everything worked fine. Thank you very much.
Water is there at the end. So if anybody needs, they can have it. Now, so next part is the programming part. So it was for developers. So we'll dive into the programming part. Well, okay, so we'll start with the coding part. So I will start with the Python programming, and Dr. Balaji will take over for the Java part. Now in Python, what my focus is on means usually when I take classes, I start from writing the code line by line, but we have a time constraint. So I will explain line by line rather than writing. Now, when you start using Python, there are several libraries. You search like RSA encryption Python, you will get so many libraries. And there are some very easy to use library, but they are not secure. So if you check their documentation, they will clearly say that we have this shortcoming. So if you are using for production, don't use me. So always be aware of what packages you are picking and from where you are picking. Now, so I will, for my demonstration, we use a cryptography package. So cryptography package, if you want to install, so for Python, you may be knowing you just have to do pip3 install and the package name, for example, cryptography. Now, currently I am not connected. I'll have to connect to internet. But if you use that, cryptography package will be installed. Now in cryptography package itself, all the required tools, for example, you require for hashing, you require for X.509 certificate creation, name object identifier, everything you will get in this itself. For signing, for padding, so everything you will get in here. So the first part of this program is to basically hash. So if you want to hash a message, there is one library, hashlib. So you just have to import hashlib in the first line. And then in the, you can define a function for hashing a message and pass the message as the parameter. And in the haslib library, you can define which hash you want. For example, here I have taken hash 256. I have passed the message by encoding it in UTF-8. And then finally, so that the final hash looks good, I'm using hex digest, which will basically convert it to hexadecimal representation. And after that, I'm simply printing whatever hash message is there. So hashing is too easy. Just import haslib, then haslib.sha256, pass it the message in the encoding UTF-8, and hex digest, which will simply convert it to a hexadecimal object. So we'll see this. I will just uncomment the last line, hash digest hash message, and we'll see if it is working fine. So I'll go to the command line and Python 3 and RSA sort.py. So you can see that it has generated the message hash. Now, next. So next part is we have to do encryption decryption, but for that first we need to generate the key pair. So for key pair generation, so I have defined this function generate RSA key pair, in which I will pass the key length and private key password. So basically, since it's a soft key, so private key, either you can encrypt it using a passkey, or you can put it without encryption also. It's a soft key anyway. Now, to generate this, the RSA, there is a RSA which I have imported from the cryptographic package. Now, most of the time we think that how will I remember this big package name from where to import? But if you are using any IDE, so IDE will help you in importing the right package. Okay, so that helps. You don't need to remember from which package I have to import it. So for generating a key, we have the function in RSA module, which is generate private key. In generate private key, I am passing the key size, which is basically key length. For example, I'm using RSA, so 1024 or 2048 bit. Once I have generated the key, I am storing it in this private key variable. And then I have to store it in some file. So for storage, we need to serialize it. For example, you may have seen about PEM format, in which I can store any public key, private keys. So for that, this line is there. So I'm encrypting the private key and serializing it using the PEM format. And the private key format is basically PKCS8. So I'm also defining that what will be the format for the private key. And finally, there are two things. One I have commented so that you know that this happens. One is serialization.no encryption. So I can, without encryption also, I can save it. And second one is where I am encrypting it with the whatever passkey is there. Okay. So both are there. We can try both. So that was the private key serialization. Then from the same private key, it contains basically both the public component and the private component. So I can extract the public component using public_key function. Again, same thing. I am encoding it to the PEM format, and the whatever public key information is there, which will be stored in the file. So now my files are here, but I have to write it to the actual storage in the operating system. So for that, I am using two files, private RSA.pem and public RSA.pem. So these two files, I'm just opening. So this is the standard syntax in Python for opening a file. So I'm opening a file in writable mode. So it is WB is basically writable binary file. So I'm opening in that, and then finally I am writing using the write function. So whatever PEM serialized private key and public key are there. So in first attempt, I am writing the private key, and in the second line, I am basically saving the public key. So I generated, converted to PEM, and then finally I am saving it in the OS using the write command. And finally I'm printing. So let me try with, I can try with suppose 2048 bit, and with passphrase, I will save it. So currently, if you see, I have only two files, ec.sort.py and rss.sort.py. And now I will generate it. So let me run this again. So you can see RSA key pair generation is successful. And if we come here, you can see here there is one private RSA which says begin encrypted private key. And second one is the public RSA, which is simply begin public key. So two keys has been generated. Now next part is the encryption part. Now for encryption, the general convention is that we can use the public key of the receiver to encrypt anything. So here we will do the same thing. So we'll open the public key. So for opening the public key, you can see RB is the mode, read binary file. So I'm reading it, and using serialization, I'm loading the key. From the file, I am loading it into this variable public key. After that, there is an encrypt function, inbuilt encrypt function. What does it take as the parameter? So one is the message. So I will take the message, encode it in UTF-8, and then I have to define the padding. So you may be aware about padding, that if the there are block ciphers, so if the message is not sufficiently large, or maybe it is over large, so in that case we can have paddings so that it becomes a full block. So in this case, we for RSA encryption, the latest secure is OAEP, which is basically optimal asymmetric encryption padding. So that I am using. In that also, I am using a mask generation function. Mask generation is basically kind of hash which generates a variable output. So we know that hash functions always produce fixed, but using mask generation, I can produce different block sizes. And for that, I'm using SHA 256 and done. So that's all it takes. So already I'm considering the public key to encrypt, and I am passing the message, and I'm defining that what padding schemes it should use. And finally, I will print the cipher text in hexadecimal. So that's why .hex, so that it looks better. So let me run this. Now, this passphrase I have already made as a variable earlier. If you see here, passphrase dev training, so which will encrypt the private key. Okay, so we'll run again. Let me comment out the key generation part, because we already have generated and saved the key. So it is giving me the encrypted message in the hexadecimal format. Now, just opposite of the encryption part is the decryption part. Difference is that encryption was done using public, so the decryption will be done using the private key. So I am reading the private key, loading into the private underscore key variable. And finally, I'm calling the decrypt function, which will again take two parameters, the padding and what do you want to decrypt. So this time my decryption is on the ciphertext. Earlier it was on the message or the plain text. Same thing, everything I'm using the same mask generation function, and the padding scheme is also again OAEP. And this way the message will be decrypted. So basically whatever I encrypted, for example, hi, I am Manu Pandey, so I should get it back the same thing. So I'll just uncomment the decrypt message and run it. So you can see that I'm getting the same decrypted message. So anyway, it was obvious. Okay, so now we'll focus on the signing part. Now signing part, this time it is opposite. So I have to take a private key for the signing, and for the verification part, I will use a public key. So that's why for the signing part, I'm opening the RSA file, private RSA.pem in the read binary mode, and loading it in the variable private key using the serialization package. And of course, I'm passing the passphrase because the file is encrypted. So I need to pass the passphrase so that it will decrypt and load. After that, I'm calling the sign function, private key.sign, in which I'm passing the message that needs to be signed and the padding escape. Now in encryption, we use OAEP, but for signing, we use PSS, which is basically probabilistic signature scheme. So it's a different, so for signing, we use PSS. Earlier, it was PKCS 1.5 version 1, but the latest one, which is 2.1, is PSS. So we should use PSS only. And finally, in the signing part, we also have to define what hashing algorithm should I use. Because as Dr. Misbah was saying, that first the message has to be converted to a digest using some hashing algorithm. And then that should be encrypted with the private key. So I'm telling that we should use SHA 256. So in that way, the digital signature will be generated. So let me uncomment this function call. Okay, so I did not comment the encrypted part. I will comment it. So this is my digital signature in the hexadecimal format. Now, the verification part will be simply opposite of whatever we did. So I have a signature. Earlier, I had a message. Now I have a signature. I have a message. And then I need public key for verification. So I am importing the public key, loading the public key basically. And then I'm calling the verify function. So already inbuilt function is there. I'm passing the signature. I'm passing the message and the padding scheme along with the hashing, which hashing was used. So if it is successful, the digital signature is valid. Otherwise, it will tell that the verification failed. So for example, let me run it. So so currently the digital signature is valid. So as you had seen that we can try to modify the message on learn.pkindia.in. And if so verification should fail in that case because the decrypted hash and the hash that we generate both will not match because the message will be changed. So let me try here itself. So like here, hi, I am Anu. Earlier I had signed hi, I am Anu. Now this is the message. I'll just add one space. That's all. And try. So it will say that it's an invalid signature.
So that's the signature verification and the signing part. And last is basically how can I generate the certificate. So we have to create a digital signature certificate. Now, earlier also it was told that if you want to generate a certificate, then you have to provide some information, country, state, locality. Then, so I'm just taking input one by one, country, state, locality, organization name, and the common name. So common name is basically for whom the certificate is being issued. Either it's a person or some FQDN if it is a server or a machine. So once I have taken this as an input, then I'm passing it to this X509 module. So it will convert it to the object identifier and save it into the subject. So basically all these information belong to a subject to which the certificate is being issued. Now this certificate, currently I don't have a CA. So I will use the self-signed certificate. So for self-signed certificate, the same subject is the signer also. So for the same subject, I am also opening the private key because he has to sign using that private key. So I'm opening the private key and loading it into this variable. Now, another thing is the certificate builder, which will basically build the certificate. Now, what does it require? So first thing it requires is the subject. So subject, just now we created this subject X.509 subject. Second thing is issuer. Now it's a self-signed certificate. So again, subject, it's the same subject. Public key, because it has to have a public key in the certificate. So from private key, I am deriving the public key. Serial number, I am randomly generating. So random serial number, it's already a function inside X509 module. Validity. So, sorry. So not valid from and not valid after. So a starting validation, validity period is starting and the ending date. And finally, sign using the private key. And for that signature, the SHA 256 will be used. So I will repeat. So I have a subject, then I have the issuer. So it's the self-signed, so same subject. Then I will have to store the public key, serial number, randomly generated, validity from, validity to, and finally sign using private key. And the hash function is SHA 256. Then I simply have to open one file in the write mode, give it some name like common name certificate.pem. And after serializing it into PEM format, I am writing this file, certfile.write, encoded in the PEM format. Binary. B is for binary. So in Python, we use a small this string literals, like F is for formatted string literal, B is for binary. Okay, so now I will uncomment this. And run. So country, so certificate is generated. So I will just see where is the certificate. So I have stored it on desktop.
demo. And this is Balaji R certificate.pem. I will open it. It's a PEM file, certificate file. In Mac, it will open with the cloud keychain. So for that, I will pass my biometric. So here I will just search for certificate. So this is the certificate, Balaji certificate. You can see it expires on 26 February 2025. It is too small, but believe me, I am saying it's 26 February. So I can open it and same IN Delhi ISC CDAC Balaji. So this is a self-signed certificate which has been generated just now, 27th Feb at 3:56. Using RSA. So that's the RSA encryption. Now, second part, we'll go to the elliptical curve, because nowadays, along with the RSA, people are using elliptical curve because I think key size is less. Okay. Now, for elliptical curve, the package is ECDSA. So Python package which you have to install, again, same command, pip3 install ECDSA. Now, from ECDSA, you have to import two keys. One is the signing key. So basically, it's the private key. And another one is the verifying key, which is the public key. So two things you have to import. And again, since signing will be involved, so I will use hashlib for the hash function, SHA 256 or 384. So we'll start with the first part where we have to generate the key pair, because hashing is again same thing. Hashlib you can use, and simply hashlib.hash256 you can use. So for private key, I am using signing key dot generate, and I'm passing it the parameter. So if you are using ECC, there are many curves. So I'm specifying which curve to use. So here I'm using P384 by NIST. So NIST 384 I'm using. You can use others also. You just have to remove it, and if I simply type NIST, you can see there are these curves. So there are other curves also. In the suggestion, you can check, and whatever is as per your policy, you can select that. And again, this time there is a simple command to PEM, which will convert it to a PEM file. And similarly, get verifying key is basically the verification key. And that also I'm converting to PEM. And finally, I'm opening one private ECDSA.pem and one public ECDSA.pem to write the public key and private key. So this will basically create a private key file, and the other one will create a public key file. So only one command to generate, and you have to pass the which curve do you want to use for ECDSA, and simply to PEM is to converting it to PEM, and finally open the open a file for storing and save it. So one for private key and one for public key. So we'll see the generation part first. So EC key pair generation successful. And then we will see here in the side that there is one private ECDSA. So you can see here begin EC private key. And then there is a public ECDSA, which is simply begin public key. So key is generated. Now next part is the signing part. Now signing is a bit easy here. Many things it takes by default. So for signing, I am opening the private key file. So I'm reading it. And then there is a sign function in which I am passing only two things, message and the hash function. I can
if I do not write anything, by default, it will take SHA 256. So you can remove it, it will still work. You just, but only thing is it will hash using 256 by default. And after hashing, basically I am saving the signature in a file dot signature. And finally, I'm printing the signature using signature.hex. Okay, so in between, whatever is going on, this all will be recorded, and this is already being recorded and it will be uploaded on our channel. We have our website pkindia.in and we have our channel youtube.com/pkindia. So where we upload all kind of tutorial. In fact, in the morning session, you saw that also, learn.pkindia.in. That is also for learning purpose only. So all the material, there are quizzes, there are papers, there are PPTs, all the material is available online. Yeah. We'll put everything. So just one function. So first I am opening the file and finally I am signing. And after signing, I am simply printing the signature. So I will just comment the generate part and run it again. And it will create one file, signature file. Oh, sorry. I should have uncommented the signature. So this is the digital signature. It's not as big as RSA because it is using ECDSA with only 256 size key. Sorry, 384. 384. And it also saves, but you cannot make sense of this.
The morning session, in the Miswak sir session, we came to know that whenever before we are doing, we will be doing the CRL also. Whether validity of certificate is there, then only we do the signing. I was looking for you in this particular code. I didn't find that CRL verification before you do the signing operation.
So it's a simple demo. Okay. And I have not included even the CRL URL. Okay. Because I don't have a CRL URL. Okay. So that's why I only included in the certificate things which can be shown for a demo.
Okay. The second question is there any demo which you will be showing along with PKCS 11 library also?
Dr. Balaji.
Achha.
Okay. Yes, sir.
When made both public and private key, you have created in both ECDSA and RSA, private and public keys, but only you will use the function like library. From one library, by invoking private key, you are getting private key. And in the same manner, you are getting public key. How public and private keys are reciprocate to each other? Because we know once private key is made, based on that, only public key will be created. Here, like suppose if you are knowing the private key, so by using this library, we can again reveal the public key, or by knowing public key, we can reveal the private key only through this library. So it means in RSA, every certificate is there, public key is there. By using this library, we can recreate the private key. I'm totally confused that.
No. I think so here, whenever I'm generating the key, so I'm generating the private key and the public key is being derived from that private key. It's a single file like P12 wala.
String is common, entire string, some portion.
From
is
there, the
private
public key component,
and
yes.
Some portion is the private one, then it's okay.
So another function is a dot public key, which will extract the public key portion
From entire string, both private and public are created simultaneously.
simultaneously.
Out of which few strings are private key, and few strings are,
Public key.
then you are.
And I am encoding it using a passphrase.
No, like that, once,
It's not
if you are
padding.
applying one function.
It's not padding. So the public key, the private key, what is doing it, he is going to extract the private key by using that's why he showed the SHA-2 physics. So there's a concept of hashing also here. So where the message is getting hashed, again it's repeated back. It's like an implication of transmitting the public key toward the extracting the private key. It's not padding concept here.
No, hashing comes later on. Na?
No,
There
sir.
No hashing, only my ETL generation where hashing comes. Hashing comes after
the message.
No, hashing comes after once you are signing the message, na? Then message digest and hashing comes, then after applying the private key to make a digital signature. But here clear things are how public private keys are being created. So I was thinking that in just some one function firing the public key function, public key generated, private key function, private keys are generated. So how both are reciprocate to each other? Because once
Single
you-
entity, some single
then
entity,
it
then
together, it together, na? Single entity in one shot, entire string was created, out of which some are.
Private key with the public key, it's not encrypted. That's what I'm trying to convey. It is a thing, it is
No, I am
extracted.
not talking about the encryption, where
Extracted.
only extraction part is there.
Okay. And finally, the last part was the verifying the ECDSA. So here for verification, I will open the signature. So I had saved it into a SIG file. Of course, you can also put it in some variable, but practically you should save it in a file because that content has to be appended to the original message. So that's why this time I saved it into a file. So I'm reading that file and this is my message. And finally, I am reading the public because I have to verify. So for verification, I need the public ECDSA. So corresponding whatever private ECDSA was there, corresponding public ECDSA I'm opening. So I'm reading from the file. And finally, I'm calling the verify function. So verify function, I'm passing three things: signature, message, and the hash function that I use for signing. So if it is successful, it will print digital signature is valid. Otherwise, I have put a try catch block, which will throw the exception. So I will uncomment it. Run it. So currently it says that digital signature is valid. So I can simply make a change. For example, I can put a space and run it again. And it will say that digital signature verification, the signature verification failed. Okay, so that's all. So I have only considered the soft part, means I am generating the public key, private key both and storing it in some file with encoding, and then demonstrated the signature process, verification process. Again, I will repeat, only thing is there are various libraries. You have to consider which is the secure one. In the disclaimer, many bloggers which have written the code, they will tell that this is not the secure part. So you take the decision on your own and don't put it in production. But this code is good. Thank you.
Is this code is on any open source software?
This is the Python package.
No. Means the code you are shown, is it available on any open source?
Yeah, their documentation is available. Na? The whatever package are there, cryptographic package, na? So there is a thorough documentation available.
Like if I wanted this code.py file, how can I get this?
Which file?
Yeah.
He is asking about your code.
Acha,
This code.
I can put it on website, my website, but anyway, I also have taken these fragments from and customized as per my demonstration. So you can also take it from the documentation which is available online, and that you can search for Python cryptographic package documentation. So current version is 42.0.3 something. 42 is the latest one. Okay.
Now Python library can be embedded in Java or any applications.
Python can be integrated. Web application you can integrate with. Framework is there.
PHP or something like.
Django framework is there. Otherwise, you can also put it as a web service. So Python will run as a web service and you call it as API.
So thank you, Anup. So this is actually going to be Java crypto programming. Anup, how do I share? Right. No, PPT. Connected.
Is there anyone who has not signed the attendance?
I need to share, right? Okay. So good evening. So now let us get into the same thing of cryptography programming in Java. Okay. So I feel that Java is more easier, but anyway, let me take it up. So I think I'm not getting this. Let me. Yeah. So a little bit of theory here. Basically, how Java cryptography architecture that we say JCA works. This is basically a provider architecture, which means they provide a specific set of APIs for digital signing, message digest generation, encryption, decryption, certificate generation, and certificate validation, etc. They keep on, they use the term CSP. The CSP stands for cryptographic service provider. Okay, so how Java has architected this particular package is slightly different from the way how the traditional other Java programs work. They are basically implementation. This is cryptography programmings are basically implementation independence is there. That means you do not, as an application developer, you do not have to implement those security algorithms, whether RSA or ECC or DS, whatever the algorithms are, or MD5 or SHA. So you can actually request the service from the cryptographic service provider. So CSP service providers would be the actual providers who would have actually implemented. So you use them. And the thing is that it's not that not only that you have to use specifically whatever Java has provided, you can actually remove Java provided libraries, and you can also use the libraries provided by others. Say, for example, Bouncy Castle. Bouncy Castle is one of the popular Java libraries which is available. And the implementation of these particular cryptographic functions, we can say that these are called basically engine classes. So basically, what Java has done is these engine classes basically you will not be able to extend them, but you can actually create an meaning you will not be directly able to create an object of it. You have to use the factory method for creating an object of it, and then you'll be able to use it. So just we will see that in more detail. So basically, JCA is an extension of the cryptographic provider, which is basically Sun JCE. And there are two terms here. API is a standard term, that is application provider interface. And second term is called as SPI, that is service provider interface, which provides the classes, interfaces, and methods which can be extended and implemented. So now, as far as the main core package which we are interested or most, which we need to note here is java.security.provider. This is the main base class for all the security providers. Every cryptographic service provider, that is, you can write your own library also. Your own, you can actually create your own implementations of RSA. You can create your own implementations of digital signing, encryption, whatever it may be. But you should adhere to these particular things. So it can actually come under java.security.provider. So each CSP contains an instance of this class, which contains the provider's name and lists all the security algorithms which it implements. So providers actually provide a complete package that have a concrete implementation of the crypto algorithms. And each Java implementation, that is Java developer kit, Java development kit, that actually has one or two providers associated with it. One is basically the Sun JC implementation. Meaning they themselves have implemented these algorithms and they provide a package for that. And all APIs, whatever Java has provided, that is actually provided through the factory method, which means you will not be able to directly create, say, for example, Java. For example, if I'm writing a class example is equal to new example, that is not possible because you try to create an object newly. Here, what you do is use a factory method for creating an object of that this thing. That factory method should be provided by that particular class. So that we'll see in a moment of time. So this is the architectural design of Java. What they have done is the application yours is the at the top, and there is a provider framework which is there, and there are multiple providers are there. Say, for example, SHA1 has been provided by provider A, B, C, and similarly 256, 255, 12. So many implementations are there. I can choose as my application developer, I can choose which algorithm or which provider to provide. Okay. So for example, I can take a provider B, MD5, as well as provider C, and then I can actually use it. So that is this particular left-hand side. Right-hand side guy actually is using both provider C for both of his implementation, while the left-hand side person is actually application is using provider B's implementation. So depending on the service providers, you can actually use it. Say, for example, Bouncy Castle and Java, both I can mix and match. That is also possible. The APIs from Bouncy Castle also will be able to use, and SunJava also will be able to use. So this is how the flexibility is given. Okay. But as far as this session is concerned, I'll be using the standard Java libraries here. And these are the core classes which we'll be discussing and using: java.security, java.security.cer, interfaces, and spec. Primarily, they are in the packages of javax.crypto, crypto interfaces, and spec. So now straight away, let us get into the program without much ado. So let us see how to generate a symmetric key in Java. So obviously, you have to import the javax.crypto package and java.math package. Math package I'm just using for displaying those keys. So you can see that the algorithm, whatever algorithm you want to use, let us say I'm just using DES, you can actually use AES also. So I have to create an object of that DES implementation. So how do I create an object of the DES implementation? So basically, I will not be able to use the new operator in Java. Actually, we don't call new as method in Java, but we call the word new as operator in Java. So by using the new operator, I will not be able to create this thing. So, but instead of that, the factory method has been given. So for example, key generator is the class which actually has the this particular implementations. So I can use key generator.get instance, and I can give the name of the algorithm. Instead of I have given here as DES. So then I will get a object of the DES DES implementation. So once I get, then actually I can generate the key. So here a symmetric key is a shared key or a secret key. So kg.generate key will actually give me the actual secret key. And then I just print it. Actually, printing is a little tougher here. So we use this big integer and then do the math here. So that is the thing. So just I will show how it is being done. I don't know. I want to show program also, sir. This other things.
If you have already explained this, what application do you use?
This is Notepad Plus, and I have to show command prompt.
Simultaneously?
Yeah, not simultaneously, one by one.
Yeah, so you tab between them.
But it's not coming there. 1 second.
You'll have to stop the PPT.
Oh, I have to stop the PPT. Okay.
PPT takes more to this.
Yeah, display you can make it duplicate.
Yeah, yeah.
No, it's
yeah.
Windows.
Okay. Just duplicate the display.
That's yeah. Thank you. So here you can see the method, whatever we discussed, the same program is here. So I'm using the command prompt. I don't know whether you are able to see this. Cursor size may be small, but font, let me increase it. Be 28. Okay. So this is anyway, I've compiled it earlier, but gen.java. So this is the output of this particular program, so which has generated the key. So you can see this. Okay. So now I can actually, if I run it again another set of random keys will be generated. So that's the thing. So that's what we got it here. New string 7F, whatever it starts. Now instead of DES, I can actually have AES also. Let me save this, recompile it, and once again run it. So this is a AES key. Okay, so this is a AES key. Of course, you know that is a 56-bit key for DES, while you have a 128-bit key for AES. Of course, there are more options, which I am not going to go into this point of time. Okay, once again, if you want to run, you can run it. So every time you run, you get a different key. So that's the thing. So let me clear. And now let me get back to this presentation. And now let us go for the next step, that is encryption and decryption. So encryption first actually there are two things. First of all, I need to set the algorithm, what algorithm I want, DES or AES. And then there is what is the buffering type I have to use, ECB. And what is the padding type I have to use. All those things, parameters I have to set first of all. Based on that, I will get that particular implemented object, that is Cypher object. So I'm going to use something called as a Cypher class here. So for using the, I need to get a Cypher object for that. As I said, I cannot write Cypher C is equal to new Cypher. That is not possible. So I have to use the factory method here, Cypher.getInstance. And then I have to mention what is the algorithm name and the padding and the buffer, everything has to be mentioned. And then for next step, I initialize that Cypher. I initialize by saying what is the mode, whether I want to encrypt or decrypt. So that I say, and then I have to give the key. What is the key I have to use for encryption or decryption? That is the thing. And finally, I have to do the operation. What is the encryption operation or decryption operation has to be done. So this is what has to be done for encryption. So once you know encryption, then things become easy for decryption also. Decryption is same. Basically, what you do here is you change the mode. Mode was previously it was encrypt mode, Cypher.encrypt mode. So now you change it to Cypher.decrypt mode. And the key is going to be same because that's a secret key and it is going to be same. And a do final method. Actually, there is a method called do final, which will do the actual operation. First is initialization of the ciphers, and then finally the do final method, which will do the actual operation. So with this, again, we are now ready to do the algorithm part. So let us go to the program. So let me get it to symmetric ciphers.java. So I have taken the DES EDE algorithm, basically with padding.
And let me actually, first of all, I need to, before doing the symmetric encryption and decryption, I need to generate the key pair. So for generating the key pair, actually, I've concatenated the two sentences. First of all, I'm getting an instance of the symmetric key cipher, that is key generator dot get instance, and finally generate the key. So that's what I'm getting, cipher dot get instance algorithm cipher. So that has been obtained. So once that is obtained, what I do is I actually do the encryption part. So encryption I have written as a separate method for people to easily understand. So you can see that two methods, this particular thing, this one is very important. This, not this one, this one. This sets up the mode, that is encrypt mode. So encrypt mode and key. So key is basically the one which we generated in the previous one. So here you created the key here. Okay, key is equal to key generator dot get instance. So this is where you got the symmetric key. So you got cipher dot encrypt mode comma the key. And then finally, what you did is, after you initialized it, you did, you need to, set the byte, meaning you need to pass the input bytes, and you call the, invoke the do final method. It will actually create the encrypted, this thing, cipher method, and it will do the symmetric encryption. So this is what will happen here. So same thing now you can think for decrypt also. Okay. Only thing is you need to change the mode. Okay. So here what happens is the encrypt mode has become decrypt mode. And for input, you have to pass the encrypted bytes, right? For decryption, you have to pass the encrypted bytes as your input. So that you pass as the input, what output you will get? You will get the plain text. Okay. So you will get the plain text, and then you have got the full data recovery. So that's what actually happens. So now let us see how it works. So Java C symmetric ciphers.java. Symmetric ciphers. Okay. So input text actually I've written in the program as hello. So, and this was the key generated. The encrypted text was this one, and decrypted text we got as hello, hello dot. Okay. So you can see the encrypted text I have given hello dot. Okay. So this is the one. So I got it here. So if I run this program once again, will I get the same encrypted text and decrypted text? Yes.
No.
Encrypted, no, right? Because the key would have, right? While decrypted, you will get the same. Okay. So as you can see that encrypted text is different because the key has become different. But anyway, decryption, you will get the same value. So this is what actually happens here. And of course, you can play around changing the text and all those things. So this is as far as this one is concerned. So now we will move ahead and move ahead with the next part. So as you know that in symmetric key cryptography, we use the same shared key for both encryption and decryption. But key sharing among untrusted entities, the challenge. That's why public key cryptography came into picture for secure key exchange. So now for public key cryptography, it is also called as asymmetric key cryptography. You always have a pair of keys. Okay, basically a pair of keys. One is called as the in the key pair, one is called as the public key, another one is called as the private key. So if you use one of the key for encryption, you have to use the other key for decryption. That is, if you use public key for encryption, then you have to use the private key for decryption. If you are using private key for encryption, then obviously you have to use the public key for decryption. So in asymmetric cryptography, we have to do these many things. First of all, you have to generate the key pair, both public key and private key. And then we will encrypt the message. We can encrypt the message with public key and then decrypt with private key. See, there is a slight subtle differences there. I just need to tell here. For digital signing, we always use our private key. Okay. And then send it to the receiver so that the receiver can use the signer's public key. Signer's public key and verify it. That is one thing. Second thing is, if I want to send some secret with you using public key cryptography, what I should do is I should encrypt with your public key so that
other than you, nobody else will be able to decrypt it. So that is the fundamental principles behind this cryptography part. So now straight away we'll get into the ways in which we can do it in Java. So again, there is instead of key generator, here we are having a key pair generator. Okay, that's the class which is available in Java. And as I said that you cannot write key pair generator, new key pair generator. We have to use the factory method for creating an object. So key pair generator dot get instance, algorithm name we have to give. I am going to give us RSA. ECC also there is a mechanism, but right now let me stick with RSA only. And I can set the key size here. Okay. As we noted that 1024, 2048, 4096, I can give the key size. So I'm going to just give us 1024 for faster computations here. And then I can generate, once I've initialized, once I set the algorithm, set the key size, now I'm ready to generate the key pair. So this is how I generate the key pair using generate key pair method. After the key pair has been generated, if I want to get the public key of that, I have to use key pair dot get public. If I want to get private key, then I have to get the get private actually. So that is the thing. So this is the code. Just let me quickly just highlight these two things. That is initializing the algorithm, getting an object of the implementation of RSA or this thing. That is number one. Number two is initialization of the key size. Number three is key pair generation. And fourth basically is public key and private key. So that is how we are going to use these methods. And before I proceed further, I just want to show you something which is very important. Actually, RSA public key will be shown to you in the screen, something of like this. But there is something called, if you break up the public key, it has something called header, which is having a modulus component. And there is a public exponent also. And there are some blank space separators also. This is as far as the public key is concerned. And if you look at private key, it has more information. See, because you know that the key pairs are generated using prime numbers. What is the prime numbers which was used? What is the exponents which were used? And what is the modulus which has been used? And the coefficients, and finally the separators. All this information, and including the algorithm version also. All of this information will be available in the private key. Okay, so this is how actually, when you look at the private key, it looks like this. So it looks so big, but it contains all of these components, modulus, prime, private component, and the exponents, etc. So this is how it looks like. So we will straight away now go into the encryption and decryption. Basically, we'll just go into the algorithm part and the implementation part. So I'll just look at the key pair generator here. So the same thing that we discussed, key pair generator, keygen, getting an instance of RSA, initializing to 1024 bit, and then generating the key pair. And then key dot get private and key dot get public. So, and then how do I print? I mean, there is another thing in Java. So we have to use this big integer object to print it. So that's what we have been doing. So now let me look at this. Pair generation. So this is how it looks like. So let me first go. My mouse is missing. Let me just once again. Okay. I'm unable to figure the mouse, but anyway, I have a touch screen, so that helps me here. So if you look at, I think it's not visible. Okay, I need to just close the presentation, I guess that's what's the reason. So this is the program, basically whatever I said, key pair generation, initialization of the key size, and then we generate the key pair, And then how do we get the public key and how do we get the private key? So that's what, and then we use the big integer for displaying. So now let me go to this CLS Java. Already I've compiled it. Okay. So what I need to do is I just need to run this program. So when I run this program, basically you can see here, key pair has been generated successfully. This is the private key. Parameters is null. What is the modulus component? What is the private exponent? And what is the public key? And the public exponent, and all those things come. And then public key is coming. And then finally private key, we are actually getting and printing it out. So this is how the complete, this thing is there. So so this is how it looks like. So here you can see that we are printing the public key and the private key. So this is how it looks like. So this is how we have generated the key pair. So now let me move further ahead. Okay, my PPT is somewhere it has gone. Let me. So this is where we got. And now let us go to the message digest algorithm. So this will help us in creating the message digest. And we can use, of course, SHA to whatever it is, but I'm just going with MD5. So first of all, we need to get an implementation of the MD5 algorithm. Okay. So that is what how are you putting? Again, you are using the factory method, get instance, and we are getting it. And after that, very important step, and this thing is, you have to, whatever you want to create a digest of that particular string, that you need to update it. You have to use the update method. Okay. You have to use the update method for writing the, meaning for actually putting up the plain text into that particular digest method. And then finally, that dot digest is the one which will actually do the signature generation. So that is what will actually happen. Okay. So these are the things. So now straight away this algorithm, you can see that I'm trying to, meaning whatever bold is important. But before that, you can see the first one, message digest MD is equal to message digest dot get instance of MD5. Okay. We are getting an implementation of the runtime implementation of the MD5 algorithm. And then I'm just giving a simple text, whatever it may be, password 1, 2, 3. You can give whatever you want. And then I have to pass this text as a byte array. So I'm doing some conversion using my text string manipulations. And then I send that particular data to the update method as an input to the update method. So this updates the input to digest. And after that, md.digest is the one which actually completes the digest operation. Okay, which actually does the digest operation. Still, the previous method is only to update the data. Okay, so actually it pushes the data to the algorithm, but it does not do anything. Okay, the next step, md.digest is what actually does the actual implementation. These nuances are slightly important because now, as you can see in further examples, we'll look at it. So this is the output. So now once again, let me go and just show the program here. So this is the one, MD5 message digest dot get instance MD5 and a string, trying to convert into a byte array, and I am passing the byte array to the update method. So basically, whatever data I have to pass it to the algorithm, that I have to pass it through this way only. Okay. Whatever input data that I need to pass it to the implementation of the algorithm, I need to pass it by md.update. And then finally, md.digest will create the actual digest thing. Okay, so this is what it looks like. So now let me Java message. So this is what is the digest which we have got for password 1, 2, 3. Now let me just have one blank space here. Okay. One blank space I have given after password 1, 2, 3. Okay. So now let me Java C message.java. Java message. So we got one blank space has given us a totally different digest value. Okay. So that's the important thing. So that's what we have got here. So that's one thing. So now let us go again back to continue with our Java program. And we will actually look into this next thing. Next thing is about digital signature, which we have been telling from morning. So here Java provides simple methods for doing a digital signing. So there is a method, there is an object, there is a class called signature, which is in java.security. The J should be small, okay. Generating signature, of course, signature dot, you have to tell now. See, you know that digital signature, first of all, you have to create a fingerprint of the message. So how will you create the fingerprint of the message? By using SHA algorithm or any other MD5 or whatever it may be, so that you can do. And then after that, what is the algorithm you are going to use for signing that? Basically, what I mean to say is the message register has to be encrypted with your private key, right? The message register has to be encrypted with your private key. For encrypting, you have to use your, what is the algorithm you are going to use? Whether you are going to use RSA or DSA, digital signature algorithm, or any other algorithm, or ECC, whatever it may be. So that you have to tell. So this is one of the implementation which has been provided. SHA-1 with the DSA has been provided, and the provider is Sun. Okay, a Bouncy Castle has a different way of doing that. So those parameters you need to look at it. And then, if I am going to do with this thing, the signature, I have to initialize first of all what I want to, which key I want to use. So that's what the private key I'm using for initializing this thing. Then finally update. Again, update is always pushing the data. Okay, pushing the data to the objects. So what data you want to sign, what is the length of it, both has to be mentioned here. So then actual sign method. Okay, so here the final one was digest. So here is similarly sign method is what which actually is going to do the digital signature for generating signature. Then similarly for verifying signature also, same thing is going to be, you are going to follow, but only thing is instead of initializing sign, you need to use initialize verify, and you have to use the public key. Okay, you need to use the public key is what you have to use instead of the private key for verification. And then input data, signature.verify, you have to pass a signature. Whatever signature you have got, that you need to pass as the input parameter. So that's what we have to do here. So again, for digital signature, we need to generate a key pair. So that's what we are doing here. And then same things, whatever I have given in bold is what you need to look at it. Update is what is the data which has to be signed. And sign method is what actually is going to give the actual signature. Okay. So then further verification. So we go for that. So let me just again take you to the code. So that may look much probably better. So I've just given a straightforward string here. You can actually take it, take input from the console also. So it depends on this thing. Then further, I just go ahead and generate a key pair. Already we have seen this. Set the algorithm, size of the key, and generate the key pair. So that we have done. Next is what we are going to digitally sign the data. So this is where we have to set the algorithm. For signing, we need to specify what is the hashing algorithm we are going to use and what is the encryption algorithm we are going to use. Okay, both we need to say as a single step. So it's not like you first create message digest and then you encrypt it. No, it is also, as far as Java is concerned, signing is one particular operation. Okay, so this is a very fundamental thing. Digital signing is one operation. Verification is another single operation, single step operation. Okay, but you need to give the algorithms whatever you want to use. So digital signing, basically SHA-1 is digest operation, and RSA is your encryption algorithm. So these algorithms you have to specify. And then after that, you initialize the signature using the private key. What is the key you are going to use? That is the private key. And then what is the data you need to sign? So that's what we have to do. And then you push the data, whichever to be updated. And then finally, you sign. So that's what we have to actually use it. So that is for signing, signature signing. And then verification is basically the same thing, but for verifying, we have to use the public key. So that's what we are using. Key.getPublic is what we are using here. And then we have to pass the input. What is our input? Signature, because that is what we have to verify, right? So that's the thing. So this is what we are trying to do. And again, data, what is the data we need to verify against? That is basically the data pushing operation, data to sign. So that is the data which we have to push for verification also. Because comparison has to happen, right? Between the data which was originally there and what is the signature you have got. So that is called that is the verification. So you need to, first of all, signature you have to do for verifying the operation, but actual data you got, that you need to push it into through the update method. So this is what we will do. And these methods, the statements in main method are basically calling these two, signing method and verifying method, and printing them. So that's what you have to do. So this is how we will do. So you can see this. This was the data we are trying to sign. That is, hello, don't share the secret. What was the private key used? This was the private key. And the signature data, basically signed data. So basically signed data is what we have got. Okay, first of all, we will get an hash of that, and then hash will be encrypted with this particular private key. So that is what we have got as a signed data. And then further we, further we got into the public key. What was the public key used? So based on the signed data, we will try decrypting that particular this thing. So we will use the public key for verification. Okay. So if you verify, then both the text has to match. Okay. So what it matches, whether it matches, that are all actually done internally by Java. So it will only give us some result, whether which is true or not, whether the data that you passed as signature and whether the data it has to be verified against the signature and the public key, whether these operations are matching or not. That's the only thing Java will tell us. So that's what it has been told. Verification result is true. Okay. So you can play around this with from our https learn.pkindia.in, where you can fiddle with your public keys and change some values here and there, and you can see that there is a failure in the result. Otherwise, this will work perfectly. Okay.
One question.
Yeah.
Go to the results.
Huh.
Here, the public key size and the signed data, I think public key contains the exponent and the modulus, and the signature can.
Private key.
Right, here, public key used.
Yeah.
So it contains both the exponent and the modulus. So the signed data is, it seems that signed data is more than the modulus. In case of RSA, I do not think it can be more than modulus size.
I'm not too sure. It's quite. What I will do is, we can actually take this as this thing. What I will do is. So you can actually look it here. Asymmetric key operations or
only contains 2 parameters.
Okay, let me take classic, this one only. One, okay, 20, okay, he has not given this. So this is a pair of keys. Okay. And then okay, I can create one certificate also. So meaning this is anyway required for my
Maybe that it is in it is shown on.
yeah, but still I need this for another example, for certificate example. I'll just anyway just I will keep this. I will go further. What was anyway that input data will not be there. Okay, so I will go to this code. Anyway, your data, because the keys are anyway going to be different, but still let me try to say the sake same input. So fingerprint generation. So this is your message digest, and then this is your public key, and then this is your digital signature, right? And then what we do is this is a thing, and this is your public key. Okay. So verify is going to give you, verification is going to be there. So now your question was basically digital signature. and the public key sizes are different, right? Or
It seems that it should be equivalent to the modular size. The signature,
yeah, that's right. Then I think in the code, whatever I have written to display that particular thing may have some. Okay, so what I have done here is, as far as the
printing.
yeah, printing is some issues there. Basically, what I have done is I have tried to get the public key and encode it. No, but the same encoding level I am doing for signed data also here. So the same hexadecimal encoding we need to do. So that's what 16 I'm trying to do here. So, but then
Signature.
hmm.
You are getting also public key.
No, sir. No. No. So that's where I'll just show you this slide. It will make things clearer. So here, if you look at it, this is a public key. Only the header and modulus are there. So here, the same actually his point was the size of your signature should be the size of your key, right? Key size.
N is the order of each dimension, so it will be linear, maybe Mn or Pn, whatever. Signature path will be always greater than the key size.
No, key, that's what. If key size is 1024 bit, signature also, as far as RSA is concerned,
So will more than that.
not really. No, sir, because what we are doing is you are actually, whatever the input text may be, you are actually making into 256 bit. If you are using SHA 1, so basically 256 bit. So
Based on that, your size.
correct. So ultimately, whatever data you are going to sign, if you're using SAT-56, your input data is going to be only 256 bits.
Matching, then it's okay. Same bit will be.
Okay.
It's not matching. Hash is fixed.
Hmm.
But after hash encryption,
Hmm.
after encrypting hash,
Hmm.
it will be different from the hash.
Yeah, it will differ from the hash, but size I'm saying.
102048 or maybe more.
Exactly, that's what they is all saying. The key size is going to be what is going to be this thing.
But never it is written that it is within the key size. Differently, once any key you are applying, and here unfortunately we are applying key on the hash value.
Exactly. Yeah. I agree. Your point is basically that if the I'm not talking about signature. If you're simply using asymmetric key, RSA key per encryption, then that point is right. But here we are actually talking about signature, because in signature the input data is always going to be the hash value size. Hash value size can be 256. Yeah, either 256 or 512. It can go. Yeah.
You are concerned if it will within the 256. That's why.
Not really. Because I will be using padding. No, my key size is 1024 bit, while input data is 256 bit.
1024 bit or it will lesser than that.
Correct. Same thing. That is the point that he is also telling actually. So, but here I feel that's what in my screen it looks same only, but we need to see how it is. He feels that signed data is actually slightly. Manish, your point was signature data is basically greater than the key size. Is what smaller than the keys.
It is correct, sir. Actually, it is adding that header part, which you are not considering. No? It's adding that.
In the public key, you have the header and modulus part.
In public key, you can see that there is 30819. This is not what we normally see. We see two integers.
Yeah, that's true.
Sequence of two integers. Now there is a header also.
So this is what in a public key you have both header and modulus, but if you look at the program, that's why you cannot actually visually compare the sizes of this thing. So this is a point here. So now let me again come back and continue with my presentation where we are. Okay, so next is the digital certificate. So here we will be using the Java. Of course, again, J is small here. There is a spelling mistake, java.security.cert. So these are the classes which are available: certificate, X509 certificate, certificate factory, cert store, etc. Of course, Anup has told about DER and PEM. So these methods are available. One of the method get issued in is deprecated now. So I'll just tell what is the thing. And of course, certificate revocation list is there, but I will not get into that right now. So basically what you will not be able to directly, I said no. In Java, as far as cryptography APIs are concerned, you will not be able to get a direct object of that particular implementation. So what they do is they provide us with one factory method. Okay. So through that, you will be able to get an object of that particular class. So what they do is, say, for example, RSA algorithm implementation they have done. They don't want you to create RSA A1 or R1 is equal to new RSA. That they don't want to do. Okay. By using the new operator, you will be create an instance of that classes, right? In Java. So that they don't want to do. So what they want to is you use this factory method, we will give you an object. So that is a factory method. So here also, by using this certificate factory, what we are going to do is we will be getting an instance of the X.509 implementation. So there is a class which actually does in Java X.509 implementation.
Or you cannot add on the.
Absolutely, sir. That's the point. So we cannot make our instance. So that's the thing. But of course, you are free to use some other. Yeah.
Similar model will come up.
Exactly. Same thing we'll have to use. That's the point. So now here actually.
Key store for Java or it is Microsoft?
No, there is a separate key store is there for Java. Key store only, JKS, Java key store. JKS is there.
Java will not talk Microsoft keys.
No, it can talk. It can talk. Yeah, it can talk.
My key sites sometimes in the system, sometimes in the dongle. And we are using Java. So how Java will instruct?
That's
system key store or other than Java key store?
No, that's the thing. No.
Java.
Yeah, correct. Absolutely. So here I just want to tell a couple of things, just 2 points. One is basically the Java key store you are using. You can actually create a key pair. You can store that in the key pair. You can load them and all those things you can do. So that is different. But we are now talking here about crypto tokens, which we buy from our certifying authorities. So for that, you actually will not be able to load it into the key store because private key cannot come out from this this particular crypto token for DSC token proprietary. So you cannot load that into this thing. So what instead we can do is we can always prompt the user to give the pin. So that way we can actually code the program. Of course, I have the program also, but I had one DLL file missing. So that's why I'm not able to show that demo. So that is that way we'll be able to prompt it. But if you want to play around with the full-fledged Java key store using hardware, obviously you have to use the Java card. So that is the point.
Here in demo, one thing is missing.
Yeah. This is no, this is mainly for developers. Yeah, I've enabled. I said I already have. I can show you a demo also. Only thing I had my actually I changed my laptop, so that configuration file actually I'm missing. pkcs11.cfg is what I was searching for. If that was there with me, I would have shown that token also. So I'll just show you that particular. I have that token tester. I think that was the program. No, it's not. It's not that thing. I need to get. Sir, this is the one. So this is the one actually you are telling about this one. So here you can actually try to use and all those things. So I was just missing this particular file. If I had this thing, I would have just played around with my own token only. So this is actually possible. Yeah, PKCS11. And this is a file actually which I was missing for. So this file, if I'm able to figure out, I previously used in Eclipse and all those things. So Now I just trying to show it in a simple this thing. So that's the thing. So anyway, that I will not get into it right now. I'll come back to digital certificate.
वो ऐड कंप्लीट हो जाएगा ना, मतलब जहां भी इंटीग्रेट करना उठाया मॉडल वो डाल दिया आगे.
Yeah, so I think we'll take it up. So this one basically, now let us take one certificate file. So this certificate file, I've taken my old certificate file, balasign.cr, which is actually eMudra certificate, whichever I taken. So that actually I need to convert into a byte array and then get an object of the X509 implementation. And then I'll generate this one, and I can now print the serial number of the certificate. I can get the public key of the certificate. I can find out the issuer. Actually, get issuer DN was basically an older method in the older version of Java. Now they have deprecated it. So now we got a get issuer X500 principle. So this is a method which they have said. So meaning this is a Java latest version 21. So that was a older one. And get signature, meaning you know that every certificate has a signature of the issuer. So that signature you can see. And the signatures algorithm name also we can get. There are many more, but I'm just sticking to with this. So now let me go to this thing. Java digital certificate. So this was my serial number of the certificate, and I used meaning the key details are public key 2048-bit keys, meaning it was an older one. Okay, it was given in 2014 and all those things, public exponent and all those things are there. Algorithm is also given as this one. So now I have another small program where I have just taken. See, if you don't have a certificate, you can actually use our https learn.pkindia.in. Just now I created a certificate. So same certificate we can take, Bala DSC. I have just kept the name here as Bala DSC temp.crt. So I will just show you that one also. So digital certificate 2, I think, yeah. So here I have whatever data I entered. Balaji Rajendran, office, CDAC, Bangalore, whatever data I gave is given here. Because it's a self-signed certificate, whatever I gave. And my details, whatever issued signature is there. And I'm using SHA-256 with RSA algorithm, meaning for generating the certificate. And all those things are available. So here also we use 2048-bit keys for in the initial beginning, if you are noted. So this is my self-signed certificate. So this is how you can do implementations using this thing. So I think we have come to the end of the session. So similarly, CRL is there. CRL, I leave it to you as a homework. So X.509 CRL, and you can actually get the revoked certificates, serial number certificates, get next update, etc. So that's it. So thanks. Yeah.
Balaji sir, this library is also support post-quantum or?
No. This does not support nothing. So this is a traditional classic cryptography. It does not support post-quantum. So, as of now. So that's the thing. Okay. So thank you. Thanks all of you. I think we can, tea is getting served outside and kits are getting ready to be distributed. I think thanks for your patient listening. We will be sharing all of this data and today's sessions and everything in our both website as well as the YouTube channel, whatever Anup was mentioning, so that we will take care. Yeah. Okay. Yeah. Thank you. Yes, sir. Yeah, please. I welcome Khan sir to say few words. Okay.
एक्चुअली आपको सीसीए ने बोला है अभी नाइट का डिनर है 6:30 जाना है ललित होटल.
ओके, थैंक यू सर.
ऑफिस चलोगे सीसीए, वहां से फिर बर्मन सर को दिया.
So while you are leaving, please take the registration bag and then go for tea. Please, sir, please, sir. It may have become full. Thank you.
First, okay. Fine. Class 3. Organization you said class 3. Individual में okay, class 2 okay. So